Good morning, 21st April 2020. Hope you are fine, but in Corona you can't be fine, that's also true. Anyhow, however, let's hope it may change soon, but it's not expected to change soon, really. It's a very grim situation, yet everybody is hopeful. Construction, industry, management, buildings, infrastructure, Bharat, India, and whole world. This industry of construction is widest one all over world. In a sense that without this, no one can survive, whether in life or in profession, in industry. This industry of construction and development, scope of work is very vast. You can say buildings, factories, industries, institutions, all infrastructure buildings, then infrastructural roads, infrastructure utilities like water supply, sewerage, rainwater, all that, railways and water resources, public health, or you can say whatever sector you take, oil, offshore, onshore, there is no sector, there is no area where you can't find this industry. Without this, nothing can move. You have to access some area. Access road itself is industry of construction. Its application starts from -2 plus. A forest requires to be converted to a city or a town. A desert requires to be constructed to habitation area, or a sea requires certain beach and resort or something else. You shall have to depend on this industry, that is construction, real estate, development, industrialization, and whatever else. We can say that 70-80% work of whole world is dependent on this industry. Whole budget, whole future scope depends on this industry. This means this industry is indispensable. If you see history, you will find works like that. You cannot do otherwise. It has been since time immemorial. Nobody knows, but it exists. There was before also. Nobody knows. In Ramayana time there were houses, and before that there were houses, there were palaces. This means maybe by terminology it was not known, but by virtuality it was known. This point is very powerful. And now, instead of art and modern world, we cannot move a single millimeter without this. We cannot fly in air without airport. We cannot produce any product without industry, without factory. We cannot live in our residence without real estate or housing. We cannot dispose our night extracta without sewer line, and we cannot drink water without water line. We cannot move without roads, without railways, without flights. If you think this is actually original work, where where humanity exists, not only humanity, where animals exist. You need camel farm, you need chicken farm, poultry farm, you need whatever, wherever, all over the world, you need this industry. This is definition of this industry, and I can claim that civil engineers are required for these industries, and in advanced modernization mechanical and electrical engineers are required for the industry, and in further digitalization all other all other professionals are required in this industry. But initiation, original work is done by civil engineer. Civil engineer means an engineer who doesn't have any, you can say, very good dressing, who doesn't have very good life, who lives in sweating atmosphere, in sun, who certainly finds some office to sit in common position, who has to walk a lot, who has to receive black face even if it is white. Civil engineer, actually, if you see from comfort angle, it's a curse, and if you see from development angle, it's a powerful gift, powerful blessing by nature, by God. Earth, earth is mother of all. Prithvi Mata we say in Hindi. Prithvi Mata. Prithvi means earth. Earth includes atmosphere. I am calling lithosphere plus atmosphere equal to earth. And this earth has hidden wealth, out of which wealth we use we use its product, its natural products, its natural resources for survival. We need all these resources. By mining we extract, by crushing we extract. We extract so much from this that you have no reply, you have no response, no retaliation to that. How can we return it back? We just user of this material, we can't return back. That is beauty of that one. For millenniums people have been using this without any gratitude, without anything, and still we are excavating it, we are exploiting it for our gains. That is where I am concerned with. It's not simply that we are gaining it, we are abusing it also. We are abusing in many ways. How we are abusing? I have told you, I have shown you many times. I'll show you something also here. How we are abusing this? We are taking out all materials from it and using for our industry, construction, for making money only, not for helping society and helping world. Unfortunately, we have not understood what we should have. Now, I want to take out from this my mobile certain file that is facilities of stores. If I see, there are photos. Yes, it is there. Let us see here. You see, let us say example, how we can make cities like this. You see, this is congested city. This is the city in Baghdad. I was there in 1981, 82 in this area. You can see how buildings have been arranged beautifully. This all has been due to materials used by after taking from earth. All these materials. So much has been used from earth. We have no response to that. And if you go further on with this, you'll find that if you take here, I'll show you something else. For example, this is a closer look at that some building. You see, there are so many buildings here. One building was taken, Thawra. This was a press building, multi-story here. You can see that here, maybe it's very wide, so you cannot clearly see. It's having tower and all that. I like to see some other sketch. If you see this tower, there is a shade here. You can see shade. This shade is of tower, and that is tower here. You can see here this one. The blackish you see, this is actually shade of this building, and this is this building here. You see on both sides are cores, and both sides are stair arrangement on the left side. One is in between, that is tower portion, and below is up to few stories. I was there in this all this building for construction of tower portion, and I worked there for around a year on that, and I'll show them. Then of course I can say are used, and if you go further here I will show you some more projects. Actually, let's say this is with the plant. Yeah, every day I'm showing this for purpose just to let you know how world is moving. This is an ethylene plant view. Ethylene plant which produces ethylene gas. Its capacity was 600 kTA, and this was having about many lakh cubic meter of concrete consumed in this, in its industrialized area, its process area, as well as in structures. There were many structures, blast resistant structures and non-blast, all in this. And this is complete night lighting. You can see there are so many towers in this, and this is really very interesting to see this kind of industrial structures. This is completely industrial city, you can say, and this is taken from Google, and this is Italian plant. It is, and that's beauty of this. You can see this is all the result of earth materials. You see there are so many metallic structures, vessels around, roads internally, foundations and all that. This is, and you can say it's another one of that. Here for example I am showing some other structure that is that is cracking furnace, which is a part of process. Means cracking means it cracks gas, it supplies cracked gas to compress for the process. It's also structural steel and all vessels with foundations. See how much work, how much material is involved in this. You can imagine, This is cracking furnace. And if you go further, I'm showing one by one just to let you understand what actually we do in field. It's not simply one. For example, this is a process area. Process area in a sense, it contains many compressors, many vessels, many foundations, mass water structure, auxiliary pyrolysis structures. It has a cracked gas compressor, ethylene compressor, propane compressor, and many other stages, seawater basin, and process areas, and various trains are there in the process areas. And this is here, this is process area actually, and this portion is administration area. You can say here administration area far away from this, which is a non-blast area. Here you can say administration building and various associated buildings with that, and also warehousing in this area. There is intake from sea, which we do like that. This all is very important from industrial life. We don't have this. We cannot deliver, we cannot refine, we cannot use industrial materials for our industries, and that's very important from economy viewpoint, from GDP viewpoint. A nation moves because of these projects, not otherwise. These projects are very time consuming, very expensive, and similarly if you take this one, same but little defined. It's little defined in details, because it is intake here from sea take. Then it goes further here, many connections, and here and you see this is really supporting administrative area, and this is called here admin, and this you can say process everything here. The same process you see complete is shown now. All see various process strains and various supporting facilities, and you can say off-sites, utilities, on-site. All this is shown here, and this seawater basin from where we supply water to whole plant for cooling purpose, and this flood tower. This water supplied and recirculated, all that. And this water is not so easy. It's taken from sea itself. It's not seen here, but you see there's another piping here which comes from intake of sea, and it's linked one, and it's big pipes in 84 inches, as you can see, ductile iron pipes. So we use the twin pipes from sea, long distance, maybe 3 kilometers long. Is that one? So it's very big one. Maybe you don't realize from this drawing or from this photo, but this vast one means this is real area actually. This one is real area where trains are. Trains are called processing trains. And it's designed there, and you got this. So this is what I say for purpose of explanation. I'm trying to tell you, and also it's a part of this. C is shown in this portion. C is shown here. This is I'm just showing you the same, but it is in takeoff C for the clarification. And you see this desert portion also is available, and desert portion other part of the site, and this is the entry of the site had that kind of construction. And this is here, outfall chambers are shown here. All that is shown in this portion. See, little is taken from Pakistan. This is all taken from Google Earth. I don't see the photograph inside. That's not promise. And this is this is exclusive industrial area. Sorry, not industrial area. This is administrative area with showing the structures. This administration building, and this is landscape properly finished one, and this is supporting buildings with the warehousing and this amenities building here. Fire building there, etc. So many other. These are all structures. You see, also complete structures are here on this. I'll go before on them. This is another glimpse of process industry portion. This is the same, but with the glimpses you can see detailing of other. Some shade is coming up. Some wait a minute. Why shade is coming? Hold on. Yeah, it's coming right now. There's some shade actually. Yes, this is I'm just trying to show you again with different angles. You see, this is cracking gas furnace here. You can see this one, and this is cracked gas furnace. Cracking gas furnace is a cracked gas compressor, and this is wash boiler, auxiliary boilers here, and here substations. This side, and you see here, these are further compressors here with complete process area and all that utilities, and this seawater. You can see all the process is shown in complete infrastructures. It looks very comprehensive from this snap, from this drawing, but it's a fact of life in industry, which you can see. This is how much expensive, you can say, maybe many $1 billion. This process, this plant is. And this is a sub plant actually, the ethylene plant. And then flare tower, how gases are disposed into environment. That's what's shown here exclusively. This is part of this flare. This is final, and if we go on to other sketch, I'll show you the another one, which is administration building area along with customer research station. This is I've shown you before. Now this is another one here. This is where customers out with material substance products, and it takes this ethylene process out. This is gate, customer research station goes out from that. It's all complete landscape one. You see, landscape one. Then we go to the other one, and that is landscape one is also this one. Complete landscape. Landscaping is soft landscape, hard landscape. Means whatever areas not there, exist no structure, or fill them with conceal those areas by grass or by plants or by footpath or by whatever means roads, all that to cover all the area, nothing to leave exposed on that. That's called landscape, hard landscape, soft landscape. That's what it's called. And all this is landscape one. You can see there are so many buildings, this way and that way. All there are. Okay, now we go further to, there's also pipe track, which is an important part of process, because metal moves through pipe, and piping is there. Because these pipe platforms or pipe racks are there. And these move here and there. This is just part of that, not whole. So this is moving here and there. This is going to the flare tower, and this side is plant piping. And we go further on to the other one. And you see complete circuit is shown here, complete very minor plant type of process. It is complete shown in different mode. and various views are shown actually, not one view. You can see complete on the seawater basin here, seawater basin here, and all this is landscape one. This unmatched, not bare one. It shows how something landscape means some areas is landscape is there where there's a machines, there's a gravel filling, compacted gravel filling. Now exclusive seawater basin, the exclusive one, or a big size one. You can see the external roads on this and how offices, how pumps are working, how this is a pump house and there's water, how it takes water from sea. These two pipes are coming from sea. I was talking 84 inches, 2 number pipes. These are that. They're coming now on the ground, but here can't see percentage ground. It's here exposed one and goes to sea water basin. From there, pumping is done, off is done, and this is transferred to plant and recirculated from there onwards. This is that one. You can see this is all here. Here complete landscape. Here gravel filling and road work and all that is done here. Let's go now to other one. And that's here another substation area, electrical one, separate one. We show substation here, and it is around is there from road work and all access to that, and landscape area and other structures here. And there's also electric substation. This is. Now I'm trying to show you actually what is done. This is not imaginary. This is actually fact one. This is a plant. It's called LNG plant. This is located in Ras Laffan. 4 tanks were there. We already done. This is 80-meter diameter tanks, and sorry, 50. About 50-meter height. You imagine this tank of a metallic tank, cryogenic steel, and around its safety is RCC or PSC. You can say containment. This was that, and you can search. This is a big, very big. You have to consider metallic tank. This cryogenic steel based, and on this is having, you can say, cupola on top. It's a dome type big cupola, and this containment is RCC or PSC. You can say tenderness of force later on. This 80 centimeters. Quite thick. You can say. I'll give you details later. No, don't have that one. That's on another one. So this is LNG tanks process here. We are involved with LNG tanks, not the complete process of that one. And here is another one that is called Record Center RCC building. This is a small mill, but it's very valuable. Wind shells were involved in that. I don't know this. Alright, this is a mobile problem actually. This is record center, electronic record center. Standby means if something is lost, some records are lost in plant. This is standby one here, parallel record stay. And that works for this guy. One is here, one is other 100 kilometers from here, 10 kilometers from here. This one is saying how work is done. And this is again shooting range. I saw him shoot this shooting range here. So just for repetition, coming in, shooting range, firing range, that's all. And now then there is, I'll show you clear. This is officers. This is offices, This is an area of army training centers, offices. Maybe not clear to you, but the photos like that. And I'll show you only. It's a very clear one because it's very useful, clear one. And okay, I think this is gone. I'll take other one. This is over. I'll take other one. This is generally all photos I've shown you for this plant. I will have to go to somewhere else, and that is I'll go to photograph as a SD card. I'll go to one. I'll show you documents here. These are knowledge contributions, as I talked to you yesterday. Knowledge contributions, I told you about changing cities, building opportunities. Now yesterday I told you this one, then I told you GGBSA. Now GGBSA I'll continue with that one because that's a very important point. GGBSA, let us see how it is. This is 90%, okay, fine. So I'll show you, I was continuing with this, this was my continuation yesterday. Explaining about this, what is it? Hold on. This was, I continued from production of very important. So I will explain to you yesterday about this, how it was, what is purpose of OPC, how OPC works, how much carbon dioxide OPC releases, and what is alternative to that. I explained to you the alternative was PFA and GGBS. That explanation I made yesterday at length. Means OPC is not very environment friendly, but it's not that we don't have anything else. We have in place of OPC, you can say, we have GGBS and we have PFA that can be used in place of OPC. By the OPC means these are used by replacement of, it's not in combination of OPC. It's whatever quantity of GGBS we use or PFA we use, we replace with OPC with same quantity, and it works accordingly. That's what it was there. I'll now, it is called supplementary cementing material. Supplementing cementing material, this is the one. It is called supplementing cementing material. You can see here supplementing cementing materials. Here then supplementing cementing materials are PFA, that's pulverized fuel ash, and GGBS, granulated blast furnace slag, that's called GGBS, and PFA is pulverized fly ash. Both are there and both are important. And you can see here granulated blast furnace slag. These are called supplementing cementing material. There's also one more cementing material, and that is micro silica or silica fumes, which is of course very expensive. We care about that, but it doesn't mean that we cannot do that. And I don't know who is there. This will disturb a lot. I don't understand why disturb what they want. Actually, they don't speak. So these are very important. You have to understand that. It's very important for us to know supplementary cementing materials, and supplementary cementing materials are this, as I told you, this fly ash, GGBS, and GGBS, and disturb me for nothing. And really, I'm very annoyed with these people, whoever they are. They don't understand. They don't realize someone is working. People are talking or disturbing them for nothing. You are not able to sleep. Doesn't mean you work if you can't sleep. So simple. I'm getting up early morning so that people don't listen, but they won't sleep. I think that's a problem. So fly ash and all that. Now I also explained to you about chemical composition of that, and also physical properties. I explained to you micro mineralogical and quality control. I ground blast furnace slag. So I explained just what is GGBS actually. That's again I remind you what is GGBS. You can read yourself in which I will speak to you. I will speak to you about this. And let me see. Holding is a problem here. Holding is the problem actually. Granulated blast furnaces like GGBS, called GGBS, and this GGBS is a non-metallic product, consisting essentially of silicates and aluminum, silicates of calcium and other bases, developed in a molten condition simultaneously with iron in a blast furnace, followed by water chilling rapidly to form glassy granulated particles, and then ground to cement furnace or finer. In concrete, GGBS reacts with Portland cement to form cementitious products. Slag possesses both cementing and pozzolanic properties. This is what it says. It's very important. I'll speak again because it's difficult to speak. Why? It says granulated blast furnace slag. GGBFS is a non-metallic product consisting essentially of silicates and aluminum, silicates of calcium and other bases, developed in a molten condition simultaneously with iron in a blast furnace, followed by water chilling rapidly to form glassy granulated particles, and then ground to cement fineness or finer. In concrete, GGBFS reacts with Portland cement to form cementitious products. Slag possesses both cementitious and pozzolanic properties, and there are chemical compositions given here which are very compared to fly ash. GGBS is usually rich in calcium and magnesium. That's what it says, So it says compared to fly ash, GGBS is usually rich in calcium and magnesium oxides for similar reasons as mentioned above. For fly ash, CSA limits as a Canadian SPAC codes limits this SO3 and sulfur content. Now, physical properties are there. Unlike fly ash, this GGBS is ground to a desired particle size. That's very important. Desired particle size or surface area, depending on degree of activation required as well as economic considerations. It's reported that slag particles less than 10 micrometer MUM, this is less than 10 micrometer, contribute to early strength development up to 28 days. Particles in 10 to 45 micron range continue to high rate beyond 28 days. So it depends and contribute to later age strength, while particles above 45 microns generally show little or no activity. Now, typically, how to obtain satisfactory strength development in concrete? Plane surface area of GGBS ranges between 4,000 to 6,000 centimeters square per gram. Plane surface area, we see what's the fineness of that. We can say 1 gram can spell how many centimeters square. That's called plane surface area. BLAIN. Plane surface area means area, or you can say specific area, which calculates fineness of that. This is 6,000 centimeters square per gram. In order to avoid disruptive expansion of concrete containing GGBS due to MgO content, this code says that maximum water plus expansion this one. So you can just have a look at this, what I'm talking about. I mean, it's better to show you on page itself, so that I'm just reading and explaining to you so that you be clear about that. I'll just refreshing you. I'll go further. This is mineral decomposition of blinded hydrogen. I'll go to directly to that. You can say I was there last time. I don't waste time on this. Already have discussed. So creep has gone, durability has gone. Now it is what actually was a property that I was reading that day, other day, and that was where is gone. Yes, this is. I was talking of this, properties, summary of general facts, as I explained to you that day, summary of that, and summary of what was, and it was regarding water demand, regarding workability, regarding bleeding, regarding setting time, regarding autogenous temperature rise, regarding, and these are all which I said, for example, in workability, or in, you can say, in water demand, we said that water demand, so fly ash, water reduction decreases, water reduction decreases, and increasing fineness and carbon content of fly ash. So fly ash means water reduction decreases with increasing fineness. So fineness increases. GGBS doesn't have a strong effect on water demand. So fly ash, a spherical particle shape of fly ash assists in improving workability. Means particles are spherical, it says, which means easily working by mixing and mix. It's clearly written here. You can see that one. Here you see here. Now, obviously says then in fly ash, GGBS it doesn't have a strong effect on slump. Means no effect on slump when we use GGBS, but increase in pumpability. Pump is easy to work when GGBS concrete is used. So fly ash bleeding and segregation are in general reduced. Bleeding, okay, I have seen still bleeding is there. It says but reduced means just see if there was no PF what would happen to concrete. That's the point here, So it says that fly ash, bleeding and segregation are in general reduced. Pumpability is improved. If, however, low bleed water may may increase risk of plastic shrinkage cracking, and GGBS doesn't have a strong effect on bleeding. These are important points. Now, fly ash, longer setting time compared to normal concrete. Normal setting time compared to normal concrete. This is fly ash, and you can say which may affect finishing schedule. Cold weather conditions may further slow setting time. Then I'll go through GGBS. Its effect on setting time is less than that of fly ash. So fly ash generally reduces risk of thermal stress. Fly ash generally reduces risk of thermal stress and cracking, especially type F and CI. It says, and GGBS may reduce risk of thermal cracking if it at least 50% use. May risk of thermal cracking, reduce risk of thermal cracking. If and plane fineness is lower than 6,000 centimeters square per gram, and if less 65% is used, and say it says that generally fly ash reduces risk of thermal stresses. So fly ash reduces risk of thermal stresses and cracking, especially if you type F and CI, and GGBS may reduce risk of thermal cracking if at least 50% is used. So if you want to avoid temperature gradient or reduce that, use 50% must be used, and plane fineness should be lower than 6,000 centimeters square per gram, and if at least 65% used in warm weather. So this is a 65% warm weather. So you have to be careful. We use actually 70% actually in some projects. Even 80% is used somewhere, you see. This is very important technical data we are giving you. I don't remember what I say, but this understanding is more important than memory. It's very, very technical data, very much technical that I'm giving you. 65%, you know. There's 65%, I think somewhere, yes. Yeah. Maybe another one. Yeah. That's 65%, right? Is there. This is very important. If using hot weather, GGBS minimum is 65% replacement of cement. And if Ganj's fine is thermal stresses are also affected, means you will be not facing much problem on curing, and though we do thermal curing. Now another property is fly ash decreases mechanical properties at early ages. Decreases mechanical property early stages, especially one day and in cold weather. Long-term mechanical properties such as compression, flexural strength, and modulus of elasticity of fly ash concrete typically superior to those of Portland cement concrete. Family of 28 days same. GGBS similarly behaves to fly ash concrete, except that concrete has higher early age mechanical properties and long-term mechanical properties compared to fly ash and similar contents. There's the other one here. This point you should have an understanding with, because when you are in field, this point counts. If you have knowledge of this point counts. Similarly here, it's fly ash. Long-term drying, shrinkage, and creep of fly ash concrete will be similar to or lower than that of Portland cement concrete of 28 days compressive strength. And GGBS appears to reduce scrape and has no significance during this drying stage. This other one here, drying shrinkage. We'll go further in this and then say it's about fly ash reduces water and chloride. Fly ash reduces water and chloride ion permeability, especially at later ages if well cured. GGBS similar. Fly ash increases protection of reinforcement steel from corrosion if well cured, and GGBS similar to fly ash. So these are 2 points you must understand. And now if you go further, fly ash, use of low calcium fly ash, with calcium oxide content less than 20% increases resistance to sulfate attack. Low calcium fly ash with calcium oxide content less than 20% increases resistance to sulfate attack. Fly ash with more than 20% CO should be investigated for sulfur resistance. GGBS content required should be investigated more than 35% required. This is very important technical points I'm telling you, which shall be very useful for you when you come across some documents of specification. And now I'll go to other point of this here. Concrete mixture proportions. I'm giving. Let me see what is this balance 84%. I'll continue, no problem. Now concrete mixture proportions here. Let me see. Difficult to handle this. Concrete mixture proportions. This is procedure for selection of mixture proportions used for Portland cement. Concrete is also applicable to concrete incorporating inclusions of either fly ash or slag with some modifications. Estimation of mixing water. Estimation of mixing water and selection of air content. Selection of water to cementitious material ratio water, cementitious material ratio W/C to meet durability and strength parameters. Calculation of cement content, calculation of coarse aggregate content, calculation of fine aggregate content, selection of admixture doses, rate adjustment for aggregate, moisture, trial batch adjustment. And if you go further here, you will find that, and that is then again say selection of water to cementitious material. Then where was this? Calculation of, I think I'm wrong here. Wait a minute, something wrong. So which point I was here? Selection of admixture doses. Okay, let me repeat again. Something happens, can't see from there. So it says that calculation of fine aggregate, calculation of coarse aggregate content, calculation of fine aggregate content, selection of admixture doses, adjustment for aggregate moisture, trial batch adjustment. Above steps may be dictated depending on method used for incorporation of fly ash GGBS in concrete. Let me check it again whether I spoke right or wrong, because a mistake can happen. It says procedures for selection of mixture proportions used for Portland cement concrete is also applicable to concrete incorporating inclusions of either fly ash or slag with some modifications. Number 1 is estimation of mixing water and selection of air content. Number 2 is selection of water to cementitious material, water over CM, to meet durability and strength parameters. Number 3 is calculation of cement content. Number 4 is calculation of coarse aggregate content. Number 5 is calculation of fine aggregate content. Number 6 is selection of admixture dosage rates. Number 7 is adjustments for aggregate of moisture. Number 8 is trial batch adjustments, and these steps may be dictated depending on method used for incorporation of fly ash GGBS in concrete. Now simple replacement method is one simple replacement method. That's how it works. Simple replacement method, is simple replacement method. It consists of a duct replacement, direct reading problem is there. Let me see how can I read best. No, it won't be best. It is best only this way. Light also is coming on by imperfection. So consists of a direct replacement of portion. I can't read like that, but let me read this way. consists of a direct replacement of portion of Portland cement by fly ash or GGBS on one. Oh my God, why is coming again? Consists of a direct replacement of a portion of Portland cement by fly ash or GGBS on one basis, either by volume or by mass, which mainly consists of modifying an existing Portland cement mix to include fly ash or GGBS without other adjustments. Concrete design with this method usually has lower performance compared to that of concrete made with Portland cement only. Let me read it again. Simple replace method consists of a direct replacement of a portion of Portland cement, that's OPC, by fly ash or GGBS on 1:1 basis, either by volume or by mass, which mainly consists of modifying an existing Portland cement mix to include fly ash or GGBS without other adjustments. Concrete designed with this method usually has lower performance compared to that of concrete made with Portland cement only. So this is simple replacement. You just by volume or by masses, you can replace OPC by either fly ash or GGBS. This is simple replacement method. I'll show you this one here. Simple replacement method. Oh my head is sitting there. What's happening? See, I lost that. Simple touch here is a problem. I have to go back again. It's a simple touch. Always you just miss your finger, you lose this. And I am depending on this, you see. I can't survive because if I read on computer this file, I can't practically do it, you see. Alright, no problem, let's move. Life is like that. Something is better than nothing, you know. So I was just doing that. So I reached there, I reached further down. It's done. Oh, it's done. Yeah, got it. Simple replacement method. Simple replacement method. You got it, you see. So this is simple replacement method. I told you about this. Direct replacement by volume or mass can do direct replacement either PFA or for GGBS. Now modified replacement method, what is Selassie? Modified replacement method and then estimation of mixing water. So modified replacement method, what it says consists of developing fly ash or GGBS concrete mixtures with similar workability and similar compressive strength to that of Portland cement concrete at a specified age. In general, these concretes have a higher total weight of cementitious materials and lower water cementing material than that of Portland cement contents. What does it mean? Let me repeat again for your understanding. First was cement replacement method, and this is modified replacement method, which says consists of developing fly ash oblique GGBS concrete mixture with similar workability of similar compressive strength to that of Portland cement concrete at a specified age. In general, these concretes have a higher total weight of cementitious materials and lower water cement ratio than that of Portland cement concrete. This what says modified replacement method, which is nothing but consists of developing fly ash GGBS concrete mixtures with similar workability and similar compressive strength to that of Portland cement concrete at a specified age. In general, these concretes have a higher total weight of cementitious materials and lower water cement ratio, estimation of mixing water. This is another one. We're going to estimation of mixing water. As mentioned earlier, use of fly ash. Let me show you on glass first. I'll read it because it's difficult to read there directly and why I'm showing you this. So this is just one. I can show you how long it is, how much it is. I'm going to read it fast for you. I think you'll be happy with that. Yeah. I'm going to read estimation of mixing water. Very important, you know. Some moisture is coming, I know why. As mentioned earlier, use of fly ash in concrete generally reduces water demand required to achieve a certain level of workability, while use of GGBS does not significantly affect water demand due to the fact that fineness can be controlled by keeping to determined limit. Degree of granulation, that is degree of granulation. Let me read it. As mentioned earlier, use of fly ash in concrete generally reduces water demand required to achieve a certain level of workability, while use of GGBFS does not significantly affect water demand due to fact that fineness can be controlled by keeping to determined limit degree of granulation. So degree of granulation is an important factor here. Therefore, for each type of fly ash and fly ash content, and same thing for GGBFS, that's a ground granulated blast furnace slag, to some extent data should be developed to replace values for different slumps and normal maximum size of aggregates. Mixing water is also dependent on sand gradation. Mixing water is also dependent on sand gradation. Unit water content of concrete mixture designed for long-term durability should be as low as practical. Unit water content of concrete mixture designed for long-term durability should be as low as practical. Consideration should always be given to using water-reducing mixtures, admixtures. Consideration should also be allowed for constructability of concrete placement. This you have to read. It's very important because it's related to durability, and that's very important. Life, that's very important. Power for concrete estimation for mixing water. This estimation is very important. It affects durability. Its effect, and this depends on both PFA as well as GGBS. I explained to you. I will repeat it also. Just you have a look on this. That whenever a time you can pause this and read this yourself. So this is a very important point. That's estimation of mixing water, which is very responsible for every act of, you can say. I'll read it again because it's important. Estimation of mixing water. As mentioned earlier, use of fly ash in concrete generally reduces water demand required to achieve a certain level of workability. It says when you are using PFA, if you use PFA or fly ash for pulverized fly ash in concrete, it impacts on water demand. It actually reduces water demand. This water cement ratio can be reduced. This is when you use PFA. While when you are using GGBS, it says something else. While use of GGBS does not significantly affect water demand due to fact that fineness can be controlled by keeping to determined limit of degree of granulation. So here is a variance in PFA. There is no such facility that we can vary, you can say, granulation size or something, or fineness we cannot change. But in GGBS, fineness is variable. We can grind it as much as possible to increase fineness and degree of granulation, size of grains, and it varies as fineness can be controlled by keeping determined limit. As degree of granulation means fineness can be increased depending on grains, and that is where fineness means there is no link to water demand. Water demand is same it doesn't reduce because finance is there. Therefore, for each type of fly ash and fly ash content, for each type of fly ash and fly ash content, and same thing for GGBS, to some extent data should be developed to replace values for different slumps and nominal maximum size of aggregate. You try that, develop data, then you can use in future. Depends on that which data should be developed for, to replace values of different slumps, various slumps and nominal maximum size aggregates. This is slump and size of aggregate or size of grains. This makes changes, this makes effect on that, but water is not affected. Water is not affected to vary. So you can say therefore for each type of fly ash and fly ash content, and same thing for GGBS, to some extent data should be developed to replace values for different slumps and nominal maximum size of aggregates. Now maximum water is also dependent on sand gradation, and you can say unit water content of concrete mixture designed for long-term durability should be as low as practical. Consideration should be given to using water reducing admixtures. Consideration should also be allowed for constructability of concrete placement. This is very important for controlling water, how to control water, and this is the one. Now we'll go selection of water cement material, water cementing material. We say cementing material is a cement, same thing means we are. Now selection of water cement material. This is the one. This is the problem. See, I want to show directly. So I can show you directly because of mobile. Otherwise, it's not possible to show directly from computer. I have fixed camera on this laptop, so I cannot show separately. And if you see another camera, and this camera stops, so that's the problem. I'm facing this kind of problem on this laptop. Those camera is fixed, it's not even swirling. So selection of water cementing material is related to durability requirement and to specified compressive strength. Usually at 28 days use of fly ash and GGBS affects strength development of concrete and compressive strength, and water cement trial batches can be made in order to develop this relationship. Design of laboratory program would preferably use a factorial design optimization method that provides with a minimum of well planned trial batches. Possibility to explore a large range of compositions relationship will also depend on type of fly ash and GGBS, type of cement used, and curing conditions and curing procedures. B. In general, to achieve similar early age strength up to 28 days as for a Portland cement, concrete, fly ash and slag concrete might require lower water cement material given I'll read it from there. Alright. Now what it says is very simple. Selection of water cementing materials. So selection of water cementing materials is related to durability requirement and to specified compressive strength, usually at 28 days. Use of fly ash and GGBS affect strength development of concrete and consequently relationship between compressive strength and WCM or W over CM of water cement material. Trial batches can be made in order to develop this relationship. Design of laboratory program would preferably use a factorial design optimization method that provides with a minimum of well-planned trial batches, possibility to explore a large range of compositions. Relationship will also depend on type of fly ash, GGBS type of cement, use and curing conditions and curing procedures. In general, to achieve similar early age strength up to 28 days as for a Portland cement concrete, fly ash and slag concrete might require lower water cementing material ratio. Given equation respecting fly ash and slag content may be satisfied. Fa 400 is a fly ash over 40 plus slag over 45 greater than 1. This is equation. Given equation respecting fly ash and slag contents may be satisfied by Fa over 40 plus S over 45 greater than 1. Maximum the water cementing material of concrete should meet defined requirements except when concrete is exposed to freezing and thawing, in which case required values should be reduced by 0.05, and also for reinforced concrete elements exposed to moisture and air with depths of cover less than 50 mm, water cementing material should not be greater than 4.4 for HV SMI FA or 40 plus S or 5 greater than 1 and not greater than 0.45 for HV SCM and FA or 30 plus SO 35 greater than 1. Just look at this on this screen and I'll move further. This is given, as you see, I see equation respecting fly ash and slag. This equation is there as I explained. So this is that one. Now I'll move to maximum water cementing material. Let me see. As well as 78%, so it's okay. I can move further. Now what it says, again I'll read for you. The equation is that also for reinforced concrete elements exposed to moisture and air with depth of cover less than 50 mm, the water cementing material should not be greater than 0.4 for HVSCMI SC cementing supplementary cementing material. HV is FA over 40 plus S over 45 is greater than 1 and not greater than 0.45 for HV SCM2, FA over 30 plus S over 35 is greater than 1. Now maximum water cementing material requirements for different CSA classes of exposure and different SCMs contents class of exposure. So there are various classes, you can see that classes yourself. Hold on to this one and see classes here. You see C11, C11, C1, C2, C, F1, F2, A1, A2, A1, A1, A2, A3, S1, S2, A3. These are various classes and these are, I'll show you this one, set, not HVSC. And let's see, these are classes and I'll see what next column is. Next column is, this first column was maximum water cement materials, maximum water cementing material ratio, requirements for different CSA classes of exposure and different SCMs contents, that is class of exposure, and then it is not HVSCM, higher volume SCM concrete. This is the one. One is not HV, SCM high volume, SCM concrete, and these are classes here. This says that 0.37, 0.4, 0.45, 0.5, 0.55, 0.4, 0.45, 0.5, 0.4, 0.45, 0.5. This is for different classes as given in column 1, which I show you before. And other one is here, that is HVSC M2 exposure exposed to freeze thaw cycle. That also is 0.37, 0.4, 0.45, 0.5, 0.55, 0.4, 0.45, 0.5, 0.4, 0.45, 0.5. In correspondence to previous one, you can see previous one yourself. And now this is here 0.37 values are given here. So HVSCM1 exposed to free thaw cycles. So this column actually gives, if you see correctly, first column gives maximum water cementing material requirements for different CSC classes. These classes I explained to you what these classes are here, and these are values here in this. Classes are there: CXL, C1, C2, C1, F2, A1, A2, A3, S1, S2, S3. Then you know, and not HVSCM, high volume SCM concrete, and this gives you 0.37 to 0.5, and then it gives you HVSCM exposed to freeze thaw cycle, which is 0.37 to 0.5, and then exposed to free thaw cycle, the other one, this is 0.3 to 0.45. These are coefficients, means for information. Now exposure losses, exposure are defined by CSA class of exposure, and exposure classes actually, exposure classes is sort of wrong. Exposure classes, which are exposure classes? These are exposure classes, you know. It is here. It is from C1 to N, and this C1 to N is this, you know. C1 exposure classes, C2, C3, C4, F1, F2, and A4. These are exposure classes, and definitions are here. Number one is definition is, definitions are here, yes. And then definition, these are two. So definition of this class example is CXL, and this is structural reinforcement. You see this one here. Let me read first. This is CXL, structurally reinforced concrete exposed to chlorides or other severe environments with or without freezing and thawing conditions, with higher durability performance expectations than C1, A1, S1 classes. This is given here: a structurally reinforced concrete exposure to chlorides or other severe environmental conditions, environment without freezing and thawing conditions. This is number one here. You can read. I give you a chance to read. They're not very clear, but some hints are there. Then I'll go to other one, that is C1. C1 is structurally reinforced concrete exposed to chlorides with or without freezing and thawing conditions. And then C2 is non-structural reinforced plain concrete exposed to chlorides and freezing and thawing. This is class C2. Then C3 class says continuously submerged concrete exposed to chlorides but not to freezing and thawing. Then C4, class C4, non-structurally reinforced concrete exposed to chlorides but not to freezing and thawing. And F1 is concrete exposed to freezing and thawing in a saturated condition but not to chlorides. Then F2 is concrete in an unsaturated condition exposed to freezing and thawing but not to chlorides. Then N, class N, is concrete exposed neither to chlorides nor to freezing and thawing. And then it is A1. A1 is structurally reinforced concrete exposed to severe manure and or silage gases with or without freezing thawing exposure. Concrete exposed to vapor above municipal sewage or industrial effluent where hydrogen sulfide gas may be generated. Then A2 is structurally reinforced concrete exposed to moderate severe manure or silage gases and liquids with or without freeze thaw exposure. Then A3 class is structurally reinforced concrete exposed to moderate severe manure and or silage gases and liquids with or without freeze thaw exposure. In a continuously submerged condition, concrete continuously submerged in municipal or industrial effluents. A4 class is non-structurally reinforced concrete exposed to moderate manure or silage gases and liquids without freeze thaw exposure. Then class S1, concrete subject to very severe sulfate exposure. S2 is concrete subject to severe sulfate exposure, and then S3 is concrete subject to moderate sulfate exposure. So these are various classes as I said, and I definitions I read for you. So this is the one, just go through this. I'll give you 2 pages here. This is the one. Definitions of that class I was showing here was a width problem. So this is, all classes are explained like this. I'll take it up so that you can. A little more here, yes. So now here. So these are complete classes, These are classes of code which I show again. Which classes are these actually? These classes are these so that you may not confuse. These are classes here. Again I tell you, this is starting from CXO, C1, C2, C3, C4, F1, F2, N, and then N. After that is N, A1, A2, A3, A1, A2, A3, and then A4, and S1, S2, S3. These are corresponding classes to what I explained to you. Now, fly ash and GGS contents, that's very important. Fly ash and GGS contents. It's very difficult to hear. Oh my God, this is getting up here, Yeah. Fly ash and GGS contents. Properties of fly ash and slag, that reacts. Why it's coming not full? Let me see. I'll reduce this one. That's okay. I'll reduce this content. Alright, this is the one. Fly ash and GGS contents. Properties of fly ash and slag, that is reactivity. Reactivity influences on water demand in concrete, influences on doses of admixtures, and variability of material shall relate to following conditions. That's what it says. It says properties of fly ash and slag, that is reactivity, influence on water demand in concrete, influence on doses of admixture, and variability of material shall relate to following considerations. And what these are: number one, required service life of structure and type of exposure to which concrete is subjected. Service life of structure and type of exposure. Number two, curing temperature, whether hot or cold weather. Number three, type of structural element. Type of structural element, vertical, horizontal. Usually suspended horizontal elements require higher early age strength for formwork removal, and all horizontal elements require more care in finishing. Other factors to be considered before determining specific percentages of supplementary cementing materials to be used in concrete in a specific region include availability of SCM, that is supplementary cementing materials, current percentage of fly ash or slag commonly used in local concrete operations applications, experience of concrete producers and contractors with use of SCM in concrete, introduction of concrete incorporation percentages of fly ash, introduction of concrete incorporating percentage of fly ash or slag higher than those used in common concrete practice in a specific region may require training of personnel in local construction industry, including cement suppliers, concrete producers, contractors and testing laboratories. So these are the points which you can say. I just show you these points for your understanding. A little more, I think. I'll continue now. 73% still there. Okay. Yes. Now, as I said, this is over. Last paragraph was introduction of concrete incorporating percentage of fly ash or slag higher than those used in common concrete practice in a specific region may require training of personnel in local construction industry, including cement suppliers, concrete producers, contractors and testing level. Now, all types of concrete applications. For all types of concrete applications, it is recommended to use. For all types of concrete applications, it's recommended to use in cold weather. Air temperature is at or below 5 degrees Celsius. I said before, temperature of concrete. So this says in cold weather, air temperature is at or below 5 degrees Celsius. Is in that case, in cold weather, air temperature is at or below 5 degrees. Minimum 15% of SCM. In cold weather, minimum 15% of supplementary cementing material, fly ash or slag or a mixture of both. In hot weather, air temperature is at or about 27 degrees Celsius, minimum 25% of SCM. So in hot weather it should be higher percentage. In cold weather it could be 15% minimum. In higher minimum 25%, so difference of 10 degrees at minimum level. So in hot weather air temperature is above 27 degrees Celsius, minimum 25% of SCM, fly ash or slag or mixture of both. This is very important point here. Means in cold weather, you can see, I'll show you better so that confusion cannot be created, Okay. all types of concrete applications. %, in cold weather, 5 degrees or below, and hot weather, this is, you can say, or about 27 degrees, this is 25%. That's what's important is. Now there's a noting here. What it says, noting is very big, and it says, understood that for some types of applications and types of SCM, it is possible, while in some cases it's required to use much higher supplementary cementing material SCM percentages in concrete than above minimums, but for some other applications and types of SCM, even the use of 15% might represent a challenge. However, objective of recommended minimum percentages is to increase average use of SCMs in cement and concrete from 10% to 20%. This is what it says. It says, however, objective of recommended minimum percentages is to increase average use of SCM in cement and concrete from 10% to 20% in order to reduce GHG emissions, greenhouse gas emissions, per meter cube of concrete produced, and also to increase durability and service life of concrete, thus promoting sustainability. This is this paragraph, you can see yourself, a very truncated view of this. Though I'll go further on this. I don't know what's the reason today, no problem at all. If you don't know what I'll go further. Now, massive concrete structures for which consideration is given to temperature rise caused by hydration of Portland cement. This is a massive concrete structures. Inclusion of high volume of fly ashes and slags in concrete is an effective way to significantly reduce heat of hydration and consequently reduce risk of thermal cracking. Recommended to use of as much fly ash and slag as possible in concrete for massive type of applications. In order to significantly reduce heat of hydration, it is recommended to use, now I'll show you first this one. Let us say you read this one. This is very important one from engineering viewpoint. I'll repeat this is important one. Massive concrete structures, which consideration is given to given temperature rise caused by hydration Portland cement. Is that one massive concrete structures, which says inclusion of high volumes of fly ashes and slags in concrete is an effective way to significantly reduce heat of hydration and consequently reduce risk of thermal cracking. Recommended to use of as much as fly ash and slag as possible in concrete for massive type of application. In order to significantly reduce heat of hydration, it is recommended to use in cold weather minimum I can't read the helmet, it's very big. In cold weather, minimum 40% of fly ash. In cold weather, minimum 40% of fly ash, minimum 50% of fly ash. So this is range. Minimum 40 to minimum 50 fly ash in cold weather. In hot weather, minimum 50% of fly ash and minimum 65% of fly ash. Well, further we move. However, it should be noted that for some fly ashes and slag, even use 65% would not be enough to reduce risk of thermal cracking. In this case, concrete mixtures should be evaluated for this particular property. So this was for fly ash issue, prevent of cracking, thermal cracking. So 40 to 50% more. So let's see what it says again for you. I'll take some water before going further. It's essential for me because water is hot and I don't want to lose that, be cold in half an hour more. So let me take some water. I know there's no one online till now, no problem. Let them sleep. They will look themselves later on. They don't like such, I think, such technical matters, maybe, or they are sleeping. I think this lockdown has made people sleep. This COVID has killed our world. Excellent. Good hydration. I had taken tea at 3 o'clock, 3:30. 3 o'clock you can say. I had taken 3:15 tea, 2 cup tea. Yet I need water because of talking. So this is that one. Now I'll move to other one, that is now concrete exposed to sulfate environment. That is very important point because sulfate environment doesn't require sulfate resin cement these days. That's why this is very interesting, technically interesting. Yes, concrete exposed to a sulfate environment. Let me read first, I will show you later. Now concrete exposed to sulfate environment says SCMs or supplementary cementing materials contents to be used to produce a concrete resistant to sulfate attacks. Let me see it works or no. Please stop. So when I take out the PowerPoint, it stops working, It works, it doesn't work, you see. That's the point, okay. It works only in charge, right? It works but doesn't move. No, it works, it doesn't work. Well, no problem. I think there was a stay and I took out the power because of some battery problem. I think this means battery is not working. It appears that. Well, let's see. SCM contents to be used, let's say SCM's contents to be used to produce a concrete resistant to sulfate attack. SCM, supplementary cementing materials contents to be used to produce a concrete resistant to sulfate attack. Depends on type of SCM used and type of sulfate exposure, moderate or severe. Regardless of weather conditions, it is recommended to use minimum 20% of fly ash, minimum. Regardless of, this is for sulfate resistant and sulfate environment, minimum 20% fly ash, minimum 35 to 55% of slag, minimum being increased with an increased sulfate exposure, severity, and increased Al2O3 content in slag. It's also possible to produce a sulfate resistant concrete by using ternary blended concrete. So this is sulfate resistant issue that I explained just now, that it says minimum is 20% fly ash when it is sulfate environment, and 35 to 55% slag when it's sulfate environment, and it should be increased further depending on content of Al2O3. It's also possible to produce a sulfate resistant concrete by using tertiary blended concrete. So this is what about you can say. It says about sulfate environment means when your sulfate environment concrete exposed to that one, you should use minimum 20% fly ash, not less than that, and 35 to 55% slag, not less than that, with an increased sulfate exposure, severity, and increased Al2O3 content in slag. So that's it. Is concrete made with reactive aggregates. This is another reactive aggregates. Recommended practice such an approach based on a risk analysis to select a minimum percent of either fly ash or slag to control alkali silica reaction in concrete. Safe SCM's contents depends on reactivity level of aggregate, type of structures, exposure conditions, and expected service life. So regardless of weather conditions, it is recommended to use minimum 25 to 35% of fly ash, minimum 35 to 50% of slag. So also possible to produce a concrete resistant to ASR by using ternary blended cement, and this is also different. Minimum 25 to 35% fly ash and minimum 35 to 50% of slag. Recommended practice suggests an approach based on risk analysis to select minimum percentage of either fly ash or slag to control all alkali silica reaction in concrete. Safe SCM content depends on reactivity level of aggregate, type of structure, exposure conditions, and expected service life. So this is minimum 25% to 35% PFA, minimum 35% to 50% of slag, and then structurally reinforced concrete exposed to chlorides with or without freezing and thawing cycling. I'm going to talk that, and I think this is time consuming. It says, let us show you this as a glimpse of this. Structural concrete to chlorides without freezing and thawing cycling. Let me now read it. Most effective way to produce concrete resistant to chloride ion penetration is by using SCM and low water cementing material ratio. I repeat, most effective way to produce concrete resistant to chloride ion penetration is by using supplementary cementing material, and a low water cementing material. In order to produce a concrete with a column, SCOULOMB, column is unit. In order to produce a concrete with a column, that is unit of chloride penetration, columns value for chloride ion penetrability less than 1500 column being a unit used for measurement of rapid chloride penetration into hardened concrete within 56 days, it is recommended to use. Well again, in order to produce a concrete with a columns value of chloride ion penetrability less than 1500 columns being a unit used for measurement of rapid chloride penetration into hardened concrete within 56 days, it is recommended to use, regardless of weather conditions, minimum 30% SCM is fly ash or slag or a mixture of both. Use of ternary blends with silica fumes. Ternary blends with silica fumes can also produce concrete with columns value less than above maximum. To achieve above columns value, concrete must properly be proportioned, correctly, properly laid, vibrated, and well cured. So this is structurally reinforced concrete with SCM. This is, let me check one more thing. This is ternary blends. Now what's ternary blends? I'll try to explain to you. Let me see how it does. Let me wait one more ternary blend. Says something. Ternary concrete mix. Ternary blends be used to exterior concrete exposed to freezing and thawing. Ternary blends have been used in concrete exposed to freezing and thawing and de-icing chemicals. Proper entrainment, adequate curing, and good concrete practices will maximize the ability of any concrete to resist freezing and thawing. So this is ternary blends of controlling cost. So ternary blend for both phases. Now it says ternary blend. What is ternary blend actually? I wanted to know. Improved possible stability in a ternary blend. So ternary blend, what is ternary blend meaning? Let us say better. Definition of ternary can be found at websites such as the Free Dictionary. Define ternary synonyms. Ternary pronunciations. So triple ternary is blending refers ternary definitions and others. Or ternary blend. Refrigerants. We need you to answer this question. Now let us see now. This is slag cement or ternary blend have been used in concrete exposed to freezing and thawing and de-icing chemicals. Proper entrainment, adequate curing, and good concrete practice will maximize ability of any concrete to resist freezing and thawing and de-icing chemicals, number of mixture proportions. So that's what a ternary blend is. So what I say is a little actually something else I wanted to see. So now we continue with that. It says that, read it again. Most effective way to produce concrete resistant to chloride ion penetration is by using SCM and low water cementing ratio, and to produce concrete with column value for chloride ion penetration is less than 1500 columns, being a unit used for measurement of rapid chloride penetration into hardened concrete within 56 days if it commenced to use. Now, regardless of weather conditions, minimum 30% SCM, fly ash or slag, minimum mixture of both. Now, use of ternary blends with silica fumes can also produce Concrete with columns value less than above minimum. Ternary, I just told you thawing it relates to heights in snow. To achieve above columns value, the concrete must be properly proportioned, correctly, properly laid, vibrated, and well cured. This is what I said about this. I'll show you again. You have this page. I'm trying to give you as much as possible regarding the supplementary cementing materials, which is very important for the current world, because people are not clear about this. But I have worked on this material on projects and I know about this, so that's why I want to share my knowledge, my experience with you people. Maybe you don't hesitate in asking this type of material from your people. But organization, hand finishing concrete flat work exposed to combination of de-icing salts and freezing and thawing cycles. This is another page. I'll show you this one. This page is also important here, though it's not that. This is hand finishing concrete flat work exposed to a combination of de-icing salts and freezing and thawing cycles. Now it says, let me read it for you. Resistance to de-icing salt scaling of concrete mixtures, including either fly ash or slag, still remains highly controversial. This resistance to de-icing salt scaling of concrete mixtures, including of either fly ash or slag, still remains highly controversial. Indeed, numerous laboratory tests that are based on test procedures have indicated that concrete mixtures including more than 20% fly ash or 25% slag often perform unsatisfactorily when exposed to freezing and thawing cycles in presence of de-icing salts. On the other hand, there are several reported cases of concrete structures including significant amounts of fly ash that have performed well when exposed to de-icing salts in field. Based on actual data, it is recommended to use in cold weather 25% maximum fly ash. 35% fly ash means in range of 25 to 35%. In hot weather, maximum 35% of fly ash, maximum 50% of fly ash. All ranges. So in hot it's more. Production of placing concrete production, that is very important point here. So I'll show you this one now. Effect of supplementary cementing material use on technical requirements such as equipment and operation, sequence of mixing of ready-mix concrete plant. Production of concrete including SCM should meet requirements for production and delivery of concrete. However, following indications should be taken into account, particularly when using high volumes of cementing materials, supplementary cementing materials, more than 30% fly ash or 35% slag. In general, fly ash has a relative bulk density much lower than that of cement, that is 2 to greater than 2.6 versus 3.15 for Portland cement and 2.9 for GGBS. Therefore, silo and weighing scale volumes may require redesign to accommodate larger volume of powder, particularly with high volume of SCMs, or be prepared to deal with possibility of double or even triple batching to make a load of concrete. As all cementing materials are pneumatically loaded into silos by either dropping or auguring, as all cementing materials are pneumatically loaded into silos by either dropping or auguring to weighing mechanism, there's a lot of potential dust, and again, due to lightness of some products, air pressure should be adjusted accordingly in silos as well as in weigh hoppers to prevent false weights. It's preferred but not always possible to auger fly ash, as it has a propensity to flow past gates. A slight incline to augers is also preferred. Well, fact is that now all concrete batching plants are well equipped with all computerized advanced arrangements, and there would be no issue as far as production and delivery or any regular quantity in line to conformance to codal provisions as well as specification requirements are concerned. Purpose of foregoing explanation was to have a review of past provisions and general arrangements. Proper planning is required ahead of pouring to receive concrete trucks within specified limits to allow adequate time of transportation and placing as well as finishing. So this is that one. This is the last one I give you. So I know placing, finishing and stripping of concrete. Placing, finishing and stripping of concrete, Placing, finishing and stripping of concrete, let me read. Just charge it little so that it will not say thank you. I can say thank you sometime. So it says use of fly ash and slag generally. Use of fly ash and slag generally increases workability while decreases segregation and bleeding of concrete, making concrete easier to place and fill forms, leading to relative ease to pump, to place, to consolidate and finish. Ternary blends of cement, fly ash, slag and silica fume with super plasticizers are very cohesive mixtures that tend to present marginal placing difficulties, particularly by bucket and crane. Let me repeat, it's very important. Use of fly ash and slag generally increases workability while decreases segregation and bleeding of concrete, making concrete easier to place and fill forms, leading to relative ease to pump, to place, to consolidate and finish. Ternary blends of cement, fly ash, slag and silica fume with super plasticizers are very cohesive mixtures that tend to present marginal placing difficulties, particularly by bucket and crane. This is the placing. Concrete made with high volume of SCM, supplementary cementing material, more than 30% fly ash or 35% slag shall often be supplied with a slump of 150 to 200 mm using super plasticizers and is very workable when slump is low, but very cohesive. Only a minimum of vibration is required to consolidate such concrete. In construction of high wall sections, external vibration shall mobilize concrete in lower lifts. This is a solution. Only a minimum of vibration is required to consolidate such concrete. In construction of high wall sections, external vibration shall mobilize concrete in lower lifts for which formwork must be designed. Once say only a minimum of vibration is required to consolidate such concrete. This is for wall, high wall. External in construction of high wall sections, external vibration shall mobilize concrete in lower lifts for which formwork must be designed for a full liquid head. Full liquid head. Internal vibrators are acceptable. However, concrete must not be over vibrated to avoid segregation. Let me read this paragraph, is very important from construction viewpoint and design viewpoint as well. Design means site work design. It says again what I say: concrete made with high volumes of SCMs, supplementary cementing materials, more than 30% fly ash or 35% slag shall often be supplied with a slump of 150 to 200 mm using superplasticizers and is very workable when slump is low but very cohesive. Only a minimum of vibration is required to consolidate such concrete. In construction of high wall sections, external vibration shall mobilize concrete in lower lifts, for which formwork must be designed for a full liquid head. Internal vibrators are acceptable. However, concrete must not be over vibrated to avoid segregation. Now, number 3, and that is significant issue herein erupts about well-designed formwork. Well-designed formwork so as to receive concrete with full pumping force without causing any side opening. Concrete pouring operations as fast-track projects on fast-track projects that require strong formwork for a suitable constructability. Read again. Significant issue herein erupts about well-designed formwork so as to receive concrete with full pumping force without causing any side openings. Concrete pouring operations as fast-track projects that require strong formwork for a suitable constructability. Finishing. Finishing says concrete with moderate level of SCM 15 to 25%, then concrete with high volume of say 30 to 35%, and then so I think these two cases is taking. Let's discuss these two cases. Number 1 is on concrete with moderate level of SCM, that is 15 to 25%. Its general view of finishes that use of moderate level of SCMs makes finishing of concrete slabs easier due to increase of workability and volume of paste. In fact, some finishers shall complain if SCM is not used in concrete. Now, concrete with high volume of SCM is greater than 30 to 35, higher than that, and low water cement material. Concrete with low water cementing material and including high volume of SCMs can present problems with finishing. Problems would be in most cases due to impact resulting from reduced water content in mix, releasing less bleed water. Oh, no problem, let me hold on. Concrete with low water cementing material and include high volumes of SCMs can present problems with finishing. Problem would be in most cases due to impact resulting from reduced water content in mix, releasing less bleed water available to condition surface of fresh concrete. Effects of low bleed water can be mitigated if diligent attention is made to control amount of surface drying on fresh concrete. By attentive care and by utilizing either a fog spray, evaporative inhibitor or mid-range water reducer compatible with fly ash system that can keep percolating for longer. Surface water sheen can be replaced while lack of moisture that results in finishing difficulties and can be eliminated or at least significantly reduced. This is very important point. Again I read this better. Concrete with high volume of SCM 30-30% more than that with low water cementing material says concrete with low water cementing material and including high volume SCMs can present problems with finishing. Problems would be in most cases due to impact resulting from reduced water content in mix, releasing less bleed water available to condition surface of fresh concrete. Effects of low bleed water can be mitigated if diligent attention is made to control amount of surface drying on fresh concrete. By attentive care and by utilizing either a fog spray, evaporative inhibitor or mid-range water reducers compatible with fly ash system that can keep workability for longer, surface water sheen can be replaced while lack of moisture that results in finishing difficulties can be eliminated or at least significantly reduced. Now, use of high volume of SCM in concrete also increases setting time, which can be positive attribute in warmer weather, allowing delays finishing operations within certain specific limit. Alternatively, set non-chloride accelerators can be used to compensate for delays in setting time. Set non-chloride accelerators can be used to compensate for delays in setting time. So use of high volume of SCM in concrete also increases setting time, which can be a positive attribute in warmer weather conditions. Always delays finishing operations within certain specific limits. Alternatively, set non-specific limits. Use of high volumes of SCM in concrete also increases setting time, which can be a positive attribute in warmer weather, allowing delays finishing operations within certain specific limits. Alternatively, set non-chloride accelerators can be used to compensate for delays in setting time. Now, other one is slabs exposed to a combination of chlorides and freezing and thawing. I'll take some water before going further. I'm feeling hydrated, so let me take some water first. What to do this time? Oh, fell down. You also fell down. Fell down now. I don't want to be sleepy, so I'm taking water. There's no problem. They are all sleeping. Let them enjoy their sleep. Time they are wasting. What to do? Just lazy. They are getting lazy, I think. has come. I think let us see what is this actually. Welcome, Mr. Ramakant. Good morning. Mr. Ramakant K. Tandon joined. Okay, welcome. Somebody has come. Well, fine. Now I'll continue. Slabs exposed to a combination of chlorides and freezing and thawing cycles. This is title. Slabs exposed to a combination of chlorides and freezing and thawing cycles, regardless of supplementary cementing materials contents in concrete. Following description provides some guides on finishing in order to improve scaling resistance of concrete. This is scaling resistance, this is very important, regardless of SCM's content in concrete. Following description provides some guidance on finishing in order to improve scaling resistance of concrete. And wait, says wait until bleeding is stopped. Wait until bleeding is stopped before final finishing operations. Keep surface damp but not wet between initial strike off and final finish. Use minimal working of surface during finishing. Avoid use of steel trowels wherever possible. Use wood trowel float. Apply curing after final finish. Membrane or moist curing compound was found to increase scaling resistance of fly ash concrete. If it's not possible to allow 1 month of maturing before first freeze or salt application, use a minimum amount of SCM. I repeat this statement again. This is regarding slabs exposed to combination of chlorides and freezing and thawing cycles, regardless of SCM's content in concrete. Following descriptions provide some guidance on finishing in order to improve scaling resistance of concrete. Number 1, wait until bleeding is stopped before final finishing operations. Keep surface damp but not wet between initial strike off and final finish. Use minimal working of surface during finishing. Avoid use of steel trowels wherever possible. Use wood trowels or floats. Apply curing after final finish. Apply curing after final finish. Membrane or moist curing compound was found to increase scaling resistance of fly ash concrete. It's not possible to allow 1 month of maturing before first freeze or salt application. Use a minimum amount of SCM. Now another one is stripping time of this, stripping time of shutters. We can now talk of that because that's also important. Depends upon setting of concrete. It is hardened now. So it's from removal or stripping of reshuttering being an operation that most of times is contingent upon realizing a predefined in situ compressive strength for respective element. In case of vertical elements, a value of 6 to 10 MPa is usually required. In case of vertical elements, a value of 6 to 10 MPa is usually required prior to stripping forms. Concrete shall easily achieve this stripping strength at 1 day or either with high volume of supplementary cementing material. That is beauty and benefit of supplementary cementing material. I repeat this paragraph. Form work removal you should say, or stripping time or deshuttering is called, being an operation that most of time is contingent upon realizing a predefined in situ compressive strength for respective element. In case of vertical elements, a value of 6 to 10 MPa is usually required prior to stripping forms. Concrete shall easily achieve this stripping strength at 1 day or even earlier with high value of SCM. Number 2, for suspended slabs, you know what is suspended slabs? You know, for suspended slabs, a higher strength is required, typically 70 to 75% of design, 28 days strength. Concrete with moderate levels of SCM, the supplementary cementing material, up to 25% shall easily achieve required stripping strength at early age. Now for concrete with high volumes of SCM, that's 30 to 35%, a judicious proportion of concrete mixture is required to achieve a required stripping strength in a timely manner. This it usually requires a reduction in WCN, incorporation of silica fumes or use of some non-chloride accelerators, particularly in cool weather. Structural designers may permit sooner stripping time for suspended slabs if properly reshowed during stripping. This is regarding stripping. It's also very technical matter. You cannot just rely on stripping. The strength concrete gets in, except for vertical members and for horizontal members. There are different times and different considerations. As said, if a concrete with high volume, the question is what volume of SCM, PFA or GBS are using, and 30 to 35%, a judicious proportion of concrete mixture is required to achieve a required stripping strength in a timely manner. Usually requires reduction in water cement ratio as well, incorporation of silica fumes or use of some non-chloride accelerators. Incorporation of silica fumes, that's called microsilica, is very expensive material, though it's very nice material. It can do both. It can delay even in reaction time also. So silica fumes very expensive yet, and use of some non-chloride accelerators, particularly in cool weather. Structural designers may permit sooner stripping time for suspended slab if properly reshowed during stripping, and reshoring is not easy. That's practically very difficult, because to take out everything from below slab and there's this walls or something else which will do not permit that, so don't do that. That's what it's saying. If you cannot strip in time, so it says use of some non-chloride accelerators, particularly in cool weather. Structural design may permit sooner strip time or suspended slabs if properly reshowed during stripping. Now coming to be kept in consideration that generally specifications do require allowance of removal of plywood or plates prior to stripping time, provided props or vertical supporting system members are kept intact until full stripping time is over, or even in some cases upper slabs are laid. Now curing objectives, curing is very well important one. That is, how many more paragraphs are there? Let me go through first. Many paragraphs more. Conclusion is there. So 2 to 3 pages or more. Let us see if we can cover it now. So curing objectives, I'll go through it. So far what we explained is various aspects of SCMs and relation to concrete, and we know SCMs are 30 SCMs. This is PFA, GGBS and microsilica. Particularly I'm talking on PFA and GGBS, which are very, very important one. PFA affects water cement ratio, while GGBS doesn't affect water cement ratio, and this impacts on durability. GGBS increases durability of concrete. There's a control, there's an expansion on GGBS consideration because its granule size, its grinding, its fineness is variable. We can increase that. But PFA is limited one, so PFA is considered lesser in importance than GGBS. GGBS is wise man. Means you can say thermal cracking is prevented if you use these materials, particularly PFA and GGBS. In fact, is very important from that point of view. Thermal cracking is reduced, which is very important for prevention of cracks in concrete, which will not at some point. If you just use OPC, it will certainly give you cracks because of fast reaction, and SCM, when you use, it will just help prevent cracks. Strength is no problem. Initial strength may be less, but strength at 28 days and further shall be same as that one, but it will give better concrete, better shape, better casting. And also a cohesive mix is produced which cohesiveness can allow you, fast vibration as well as external vibration required in deep members. If there are members which are deep and you are not possible to take to the vibration from inside, and an external vibration can work in that case. It depends upon how you take this in. That's the reason I'm trying to explain some chemical properties of these materials, which are three metals, particularly PFA, GGS, and microsilica. Microsilica has very good property. I'm not explaining here. It means if you just 8 to 9% of microsilica in concrete, you can enhance time even to compact that concrete site. Suppose you have left it for 3-4 hours on site, concrete laid from your pump. Even then it doesn't set in without application of vibrators. But this happens in case of microsilica, only not happens in GGBS. GGBS doesn't hang particles, which supports particles in a cohesive manner. So cohesive and expansive are different, adhesive or cohesive. So in that case, microsilica case, you have to apply vibrator only, then it starts to work. While in case of PFA or GGBS, it starts working that way. So GGBS and MS are really applicable in industry because MS is not applicable. It's quite expensive. Silica fumes, which are very important part. Silica fumes means fumes of silica, lesser particle size and smoke particle, and goes into cement particles and coat on that. And coating on cement particles is suspending suspension by this one. So all particles are coated by this. So there's a jail of suspension of these elements. That's why I say it's important to understand why is that. Let me go now again to finishes. I think finishes. Yeah. Let's say what's this? Objectives. So objectives are curing objectives. Okay, fine. Now there are certain criteria that should be met by curing. What is the criteria? Let me see him, otherwise this system goes. His name will also go away. I want to recall his name. Name will also go away. That's the problem. Thanks. I can say thanks. So it's okay. Because now I move to curing objectives. There are certain criteria that should be met by curing, and a satisfactory moisture content needs to be maintained. That says a satisfactory moisture content needs to be maintained so that hydration of cementitious materials continues long enough so as to have achieved required strength, durability and impermeability, while shrinkage induced cracking is minimized. Is that what says? It says that a satisfactory moisture content, moisture content needs to be maintained so that hydration of cementitious materials continues long enough so as to have achieved required strength, durability and impermeability. Strength, durability and impermeability are very important factors, while shrinkage, induced cracks are minimized. It's very important point here. It says that what is these people disturbing for? I don't understand. Unnecessary calling. Bhanu, Bhakra, Kola, what people don't know. A satisfactory moisture content which affects properties of strength, durability and impermeability. If durability is increased, concrete is better. If strength is increased, concrete is better. If impermeability is increased, impermeability means when water doesn't pass into that, it doesn't affect concrete. These three properties are very important from that point of view. So you can say shrinkage induced cracking is minimized. Now concrete and ambient temperatures affect the rate of hydration. Concrete and ambient temperature affects rate of hydration and ultimate strength of concrete, suitable minimum or maximum. Why they're not stopping this guy? Problem with this guy, I don't understand. Concrete and ambient temperature affect rate of hydration and ultimate concrete and ambient temperatures. Concrete and ambient temperatures affect rate of hydration and ultimate strength of concrete. Suitable minimum and maximum temperature limits are necessary. This is the main point. Welcome, Mr. Gulam. Good morning. So concrete and ambient temperatures affect rate of hydration and ultimate strength of concrete. Suitable minimum and maximum temperature limits are necessary. Temperature I always say is very important from concrete, from its durability point of view, from atomic structure point of view. But here people do not realize value of temperature of concrete, minimum, maximum. Well, doesn't matter. Temperature differentials within concrete and between surfaces of concrete and ambient temperatures need to be controlled so that deleterious thermal cracking is eliminated. Permissible temperature gradients are dependent on size and geometry of concrete section. As mentioned, use of fly ash and slag generally reduce risks of thermal cracking. I repeat this paragraph, temperature is very important. Temperature differentials means differential temperature variation within concrete itself, concrete and between surfaces of concrete. This end is this temperature, other end is this temperature. That's the question. Temperature differentials within concrete and between surfaces of concrete and ambient temperatures need be controlled so that deleterious thermal cracking is eliminated. Deleterious thermal cracking, this is a point here. Thermal cracking leads to cracking and reduction of life, and that's all. So we have to control these cracks, very important point. We have to control by using supplementary cementing materials. That's the only answer. So it says that temperature differentials within concrete and between surfaces of concrete and ambient temperature needs to be controlled so that deleterious thermal cracking is eliminated. Permissible temperature gradients are dependent on size and geometry of concrete section. As mentioned, use of fly ash and slag generally reduce risk of thermal cracking. So solution is approximate solution, use of slag and use of PFA by replacing OPC to that extent. Now on many massive blocks nowadays a new concept of thermal curing is adopted which uses no allowance of evaporation of water used for concrete mixing. Complete curing is affected by heat generated by within massive block designed for thick as well as massive foundations or other structures. This method utilizes heat generated due to thermal gradient and same energy is consumed for excellent curing of concrete within block. On many major fundamental major foundations on major plant facilities, such activities of curing is affected by including GGVS concrete to a replacement between 55 to 70%, maintaining concrete temperature below 24 degrees Celsius. This is a point here. I repeat this very important paragraph of temperature. It takes time, no problem, but one should clearly understand value of that, impact of that. On many massive blocks means big blocks, not small foundation. It should be more than 8 cubic meter to an limit, whatever say. And this is very big foundations like machine foundations or like very big equipment foundation or vessel foundation, where the thickness is much more, minimum thickness is much more than 1 meter or 80 centimeter, and dimensions should just means there are two, again I say, one is thin concrete, one is thick concrete, one is massive block. There are three characteristics. Thin concrete means your building itself, slab is thin, column is thin, beam is thin, foundation, all these are thin one. Then you say 8 cubic meter quantity minimum and 80 centimeter diameter minimum, not diameter, 80 centimeter dimension. 0.8, now say 1 meter, so you can say 1 meter dimension minimum 80 to 80 centimeter to 100 centimeter dimension minimum one, and quantity being 8 cubic meter, that is called thick element, and more than that is thin massive element. These are three categories of members of concrete within a structure. On many massive blocks, so you can say on many massive blocks nowadays a new concept of thermal curing is adopted. Is no allowance of evaporation of water using for concrete mixing. No water from concrete mix should be used for concrete curing, and complete curing is affected by heat generated from within mass. Means whatever heat generated within concrete, we don't allow to release this, we don't evaporate this, keep it inside. And by heat generated from within massive block, you see what it says, that thermal curing is adopted which uses no allowance of evaporation of water used for concrete mix. Complete curing is affected by heat generated from within massive block designed for thick as well as massive foundations or other structures. Method utilizes heat generated. This method utilizes heat generated due to thermal gradients, and some same energy is to consumed for excellent curing of concrete within block. Curing of concrete within block by heat generated, not to allow it to go away. On many major foundations, on major plant facilities, such activity of curing is affected by including GGBS concrete to a replacement factor of 55 to 70, maintaining concrete temperature. Combination of membrane curing and water curing. Combination of membrane curing, I mean to say curing compound, that's called membrane curing, because it establishes a membrane of curing compound on surface of concrete. When you spray this, it may be, you can say, water based curing compound, or it may be wax based curing compound. Both establish a membrane on surface. So it's called combination of membrane curing. And water curing is also very effective on other elements that require immediate application of water based curing compound, followed by common procedure curing, so that concrete temperature is maintained within defined limits. Now I'll go to what designs are there regarding curing. Let me just see these formula please. Let me take this Mr. Gulam and Mr. Hari Ram. Welcome Mr. Hari Ram. Welcome Mr. Hari Ram, Mr. Gulam. Let me name entered so that it should be on record. Thanks. Alright, now I'll go to other one. Now there was such allowable curing designs according to parallel specifications. Curing designs 1, 2 and 3. These are 3 curing designs. Says that name is basic, additional, extended, and description says that, let me see what it says. I like to show what percentage is 73. So I'll take out from here. I'll show you that from here. Okay. This is what design says. Let me squeeze this. Here is here. Curing designs. See. 1, 2 and 3 designs here, and this detail is shown just like basic, additional, extended, and its details are here, descriptions are here. So what this I'll read for you. Allowable curing designs, curing design number 1, number 2, number 3, according to CSA, the Canadian specifications. So name is basic, additional and extended. Number 1 is basic, number 2 is additional, number 3 is extended. Then description says number 1, 3-day at greater or equal to 10 degrees Celsius or for a time necessary to attain 40% of spatial strength. Number 2 that is additional, like 7 day at greater than or equal to 10 degrees Celsius and for a time necessary to attain 70% of specific strength. And number 3, that is extended one, that is wet curing period of 7 days. Curing type allowed are ponding, continuous sprinkling, absorptive mat, or fabric kept continuously wet. These 3. So 1 is 3 days, that is basic one. Curing design number 1, that is basic one, that's for 3 days at greater than or equal to 10 degrees Celsius for a time necessary to attain 40% of strength. And then additional design, which is number 2, 7 days at greater than or equal to 10 degrees Celsius and for time necessary to attain 70% of specified strength. And then extended design, that is wet curing period of 7 days. Curing type allowed are pondings, continuous sprinkling, absorptive mat, or fabric kept continuously. These are designs in the specification. Now further, that a formed component, which you know. So it says that. Okay, now it says for formed components. Form means a formwork is there. For form components, living form leaving forms in place until above criteria are met. These criteria, design number 1, design number design 3, that was for 3 days, 7 days and more than days. For formed components, leaving forms in place until above criteria are met, complies with intent of basic and additional curing regimes. If forms are removed earlier, concrete components should be wrapped in plastic or coated uniformly in line to manufacturer's recommendation. Rate of application with a high quality membrane, curing compound, or be kept wet by application of water through soakers, hoses, or fog sprays. Let me read it again. This is a different one. For formed components, components where form work exists, not unformed. For those formed components members, leaving forms in place until above criteria means class number 1, 2, 3, which it says that basic, additional, extended, 3 days, 7 days and more. This is that one. So for formed components having forms in place until above criteria are met, complies with intent of basic and additional curing regimes. If forms are removed earlier, concrete components should be wrapped in plastic or coated uniformly in line to manufacturer's recommended rate of application. I don't understand. Yeah. Okay. So let me repeat it. If forms are removed earlier, concrete components should be wrapped in plastic or coated uniformly in line to manufacturer's recommended rate of application with a high quality membrane, curing compound, or be kept wet by application of water through soakers, hoses, or fog spray. Number 2 is for flat work maintenance in moist conditions. Flat work maintenance in moist conditions is needed not only to promote hydration but also to reduce drying shrinkage that could lead to excessive cracking. Moisture can be applied by fog sprays or by covering with pre-soaked burlap or proprietary mats that hold moisture. Covering soaked Haitians with polyethylene with with polyethylene covering soaked Haitians with polyethylene sheets can reduce water loss. Actually what happens, we people don't understand curing. We just use some Haitian bags or gunny bags and put on that and say it's done. No, that's not correct. You have to keep that Haitian saturated and covered with polythene sheet so that polythene sheet protects water evaporation, because gunny bags or your Haitian shall allow evaporation of water. It's not protected by polythene sheet, and that's purpose that's a covering is polythene sheet, and it doesn't stay in due to air. You can tie it with something so that it rains there and air doesn't blow it away. That's the purpose of it. So it says that covering soaked Haitians and polythene sheets can reduce water loss. Weather conditions requiring special protection of flat work to avoid developing cracking quickly. Proper planning should undergo before pouring concreting starts so that materials and equipments are available on site whenever required to be used. Now, there is no difference between curing a Portland cement concrete and a Portland cement concrete and a concrete with SCM contents. SCM contents less than 30 to 35%. For concrete with higher volume of SCM or supplementary cementing material, curing regime becomes more stringent. Again, there is no difference between curing a Portland cement concrete and a concrete with supplementary cementing material. There is no difference between pouring a Portland cement concrete and its concrete with supplementing cementing material contents less than 30 to 35%. For concrete with higher volumes of SCM, curing regime becomes more stringent. So I am talking of that one. Higher regime I'm talking here. condition. Although there is no difference in specified curing for conventional concrete and SCM concrete, with SCM contents less than 30 to 35%, SCM contents must be cured as specified, prepared as it is less forgiving than conventional concrete. Conventional concrete. It's also suggested that designer or engineer responsible should make a note on the specifications or drawings about the degree of required curing. Arrangements to produce a specific concrete. It was experienced on one project where even concrete spacers procured from proprietary vendor, while these two were tested for alkali silica reaction were, were tested for alkali silica reaction as well as for rapid chloride penetration. So you can say it was experienced on one project where even concrete spacers were procured from proprietary vendor, while these two were laid. Okay. Then we had to protect alkali silica reaction as well as for rapid chloride penetration. Rapid chloride penetration is a route that corrodes steel, and these rapid chlorides enter after 56 days of hardened concrete. This causes very dangerous since their volume entries in columns. I tell you last pages of this recently. So you have to go through that. Only then we can understand what we are doing. On site, when I demand something, I don't get it. That's very okay. Now conclusion is concrete should be placed using SCM. This conclusion, concrete should be placed using supplementary cementing material to achieve better production, better placement, better curing, better protection and from plastic cracking, better site controls as well as to achieve durability, which is mainly affected by reduced rapid chloride penetration. Impacts rapid chloride penetration means it is a process that enters into concrete body through cover, and this rapid chloride penetration, if successfully enters your concrete, of course shall work to corrode concrete by penetrating through body of concrete. Then steel, when steel goes down, it is eaten and crumbled. What is meaning of other party? Should understand that. Now, so concrete should be placed using SCMs to achieve better production, better placement, better curing, better protection from plastic cracking to achieve now better site controls as well as to achieve durability, which is mainly affected by reduction of rapid chloride. So reduction of rapid chloride penetration impacts advanced arrangement required for suitable forms and receiving concrete deliveries. Do not permit any lapse on any activity during concrete from trial design to finishing on site and cures. So this is effect of conclusion. You can say supplementary cementing material must be used. So what actually we have gone through this file. So I'll tell you, this is a big file. It's a big file, and I explained to you all details, and this file is very important from engineering point of view. And this file is long one, not too long, but expressive, you can say. And I just briefly outline what we have talked about this. So this file is still I am searching it. This title. This file is come on now. Yes. This is that. This is title of this. Production. This is long file. This is actually title means we are going to produce concrete. You see, production of every ton of Portland cement and essential constituent of concrete releases about 1 ton of concrete, component of concrete size. And this file is the title. So in this we studied partial replacement of SCM for GHG concrete, or you can say to reduce greenhouse emissions, greenhouse gas emission, if we use this PFA and GGBS. The other was that this was not clear. We got it better. Supplementary cement and materials. What are they? This is that. Then typical fly ash and SCM, what are they? Then on top of this, well, this is what I gone through this quality controls and mineralogical composition and ground gravity blast specifications and physical properties. Then also gone through chemical steel and chemical systems, and then it's gone through declaration of this and concrete designs they go through. So what I'm saying is, now I'll go to some other file, which is this was GGBS PFA concrete durability CFE 26. Now of course there is another one that is actually practical technical queries of concrete. I just give you answers to questions or taken by someone else, and that is practical technical queries of concrete part applies. Now it says one answer is large footing to be designated as massive block or thick members do not require vertical defined joints. Question is not explicitly clear what size. It is one question actually. You say massive block where you cast. It's possible to cast in one go. If you provide joints, it faces some problems because these are all in-depth members, not small depth members. So controlling of joints is very difficult. As far as possible, the point is not too big like raftings. You should try to with one block maximum casting. And of course joints, construction joints in stepping, this means cold joints should be avoided. Current practice for massive blocks, concreting is effective using 70% GGBS replacement or combination of GGBS oblique PFA, so-called SCMs replacement of cement. Then vertical joints are conducted by virtual stepping mode, concreting in secure sequences so that cold joints are avoided. Differential thermocouples are inserted to monitor thermal gradient. That's very important. Thermal gradient is a point maybe we are not clear. Depth is more, width is more, volume is more. What temperature they are lower concrete, what temperature in middle concrete, what temperature in top concrete, in varying section, varying length. That temperature in concrete during laying and setting must be known just to get what value of thermal gradient is there. That thermal gradient should not be much, there should be much difference. For that purpose, some thermocouples are inserted to monitor thermal gradients. That's differential thermocouples are inserted to monitor thermal gradients. That's purpose of that I'm talking anymore. So it's that I know. So normal curing is not carried out, but thermal curing. Thermal curing I explained before, I'll explain again, no problem. Let me go further. I'll explain thermal curing. Normal curing is not done. In case of vertical joints, limitations of concrete volumes required. If so, agree for joint formation, vertical joint is formed using metallic shutters. an intermediate division with reinforcing bars continuity. In case construction joints are required, steel remains continuous so that cannot stop there, but metallic sheets are inserted to be used as permanent shutters. We won't take them out, but on other part we'll put it in so that that remains as permanent shutters. Uh, then and in case of vertical joints, limitations for concrete volume is required. If so, actually for joint formation, vertical joint is formed using metallic shutters at an intermediate division with reinforcing bar continuity. And then question about repropping pertinent PT slab is not clear. PT slab, pre-tension slab, post-tension because not pre-tension, post-tension slab. This is a PT slab can directly be put on cast in situ beams for slab formation used as permanent forms on which diaphragm constituent is of cast in concrete is placed. What is that actually? This fast tracking projects, we have to use two types of members. One member is column and beam. It's cast in situ, which are done on site, while we bring hollow cast members, or you can say hollow cast slabs done or produced from factory itself and transported to site and installed there on those beams, and later on those beams a slab is laid on those hollow call slab thin slab is laid, which converts those complete hollow core slabs into diaphragm action, which is necessary to resist horizontal forces. So that's called column. Then the questions about, because these hollow cores are post tension and they're brought to site, and that's the way. And columns started bars are placed from stuck columns followed by full length bar covering up to floor zero. Well, okay. Now there's one point here. Columns, when we say started bars are placed from stuck columns, that's for column within earth, within filling, followed by full length bar covering up to floor zero, bending moment locations, avoiding moment area. Now certain explanations I'll give on this. Now couplers should be used for higher diameter bars, 325 conveniently above. Since difficult to work on for higher bars, overlapping is not permitted, or you can say it's not preferred either. Yet prior to deciding on inclusion of couplers, practical tests for retention should be conducted by a specific testing equipment. And then couplers can be used in both compression as well as in tension bars without causing any problem, but staggering should be affected. Practically contemplating only one grade should be included for whole floor from control viewpoint. Use of different grades do cause deliveries issues, and columns cap concrete variation. Concrete pavers, now question is concrete pavers. This was actually certain questions were asked and applied to the 49 Newton is used for concrete grade and 80 millimeter for traffic area and 60 millimeter for walking area. And curing compound is good replacement for water, but should be selected with caution. Two types of compound used to be available: wax based and water based. I explained just now. Wax based forms a gelatinous layer on concrete surface which takes about 6 months for natural degradation or scrap is used to deteriorate it when plastering or rendering is required earlier. Water based curing compounds partly effective only since it evaporates easily. Prior to use of compound, water should be sprinkled on vertical surface so that it retains within formed gelatinous layer. Actually curing compound is never 100% effective on horizontal members that are accessible during curing duration. In addition to curing compound, water curing should be supplemented. Compound should be used only for avoiding initial crack formation of thermal cracks, not only on cast and situ. Now there's some more points here. Let me read those points and will explain. Not only on cast and situ piles, but on all cast and situ concrete reinforcing bars quantity for all concrete ordering purposes should be deducted from theoretical quantity. But for estimation purpose, no such deduction is permissible. A percentage variation should be conducted for perimeter surfaces for piles depending on soil nature. Otherwise, compressive characteristic strength is object for standard strength measurement for practical approval of concrete. But testing can be conducted on whether number of days, 56 days, age of concrete is a must for load testing purpose. And another one is In certain case, when striking shutter is required on earlier basis, even say 3 days testing can be conducted to confirm or ensure that what strength concrete is received, achieved, and cycle of 12 days can be achieved with no issues irrespective of considerations of 40 Newton depending on availability of resources and strength of working team and allied services, coordination and inspection issue, which means even cast in situ slab can be converted to fast track without using hollow core slabs. Then certainly soiling and grading below foundation, improved bearing capacity and also access filter as well as protection as it is isolated from effect of soil, and then such capability occurs. It doesn't harm concrete to considerable extent, and clay soil can be used for filling purpose in combination with desert fill and sand soil, keeping liquid limit within 35 and plasticity index below 6. It's suggested a non-plastic soil should be used for filling purpose, and columns are designed for direct load as well as for moments, while shear wall is meant for primarily lateral load. Now, I'll give a brief on these points just now for explanation, whatever I can give, so that it should be clear, because these are raising certain similar questions and I've answered them. I could not write questions on this. It says that now we say large footing, or you can say massive block, which is a very dependable element of foundation for machines or for vessels or for something else like that. So this is not thick member, this is a massive block. As I explained, thick member is 8 cubic meter, 80 to 100 centimeter minimum dimension, and more than that is massive block. So in this case, large footings to be designated massive blocks of thick members do not require vertical defined joints, as I explained before. Avoid joints for practical purpose, it's better, and if we can't avoid that, then we have to provide construction joint, which means construction joint should not be temporary, it should be permanent by using metallic shields as is done in rafts, deep rafts, and that should allow penetration of steel through it, or you can take that in two sections, up and down, and means you have to care for that practically and let it remain there forever and do next stage concrete, and that's called massive joint or massive block construction joint. Then it's for, question is for, and in that also one more question answer is, in this massive block, temperature of concrete should not increase 24 degrees Celsius, otherwise it will cause problem of curing, heat production, and because this is massive block, we cannot permit flooding of water curing, or water based curing is not permitted there. It doesn't work at all in massive block, practically speaking. It doesn't work there because water does not reach every part of that concrete due to its limitations, and that point must be understood very clearly, which people do not, and it causes a problem actually. Let me just a minute please. What I have to say, can get my point that I am saying is, in massive block where temperature is 24 degrees Celsius, if you increase that, it doesn't work. It leads to thermal cracking, and in deep depth of foundations, we have to make sure that heat generated due to chemical reactions between cement and water should not be allowed to go off. That heat should work within it for purpose of curing rather than being allowed to evaporate like as we do in normal curing. Purpose of curing is to replenish water loss due to evaporation, but we have to confine in massive block that heat by whatever method. That method is called thermal curing. I mean to say you have to seal that surface of exposed concrete, exposed surface, and tighten so that no heat is released from that area, because other areas are of course shuttered, formed, and we have to make sure that temperature of that during curing remains within limits, and heat is not released from that surface. That is beauty of that concrete, and that is thermal curing, because using heat only for purpose of curing. Medium is heat that cures that concrete. You can experiment that also if you wish. There's a column you cast, don't cure it, just close from top and see temperature outside. If temperature permits that, automatic curing goes on. If temperature doesn't permit, you can apply external curing on that formwork. So that is purpose of this. Now I say current practice is for massive blocks. Concreting is affected using 70% GGBS replacement, or a combination of GGBS PFA, so-called SCM, supplementary cementing material replacement of cement. I explained to you a lot on this chapter. Vertical joints are conducted. Vertical joints are conducted by virtual stepping mode. That's important. Yes, importance is in your massive block. I've shown you many times on this. The stepping concrete is very important in that. And what is the meaning of stepping is that whatever you have, massive block you have, you cannot just lay one concrete layer there. That's not correct. You have to see length of that concrete, whatever meter it is, let us say 25 meter long or 50 meter long. Then you have to provide layers on the other side, widthwise side, say 2 meter layer, 3 meters width, like that, strips there, and then various strips of that. There may be 40 centimeter one time, or you can do not more than that, 40 centimeter or 35 to 40, depending upon nozzle size. Even with 30 centimeter, and how many strips coming vertically, let us say 2 meters, 7 or 6 strips coming vertically. So those 7 or 6 strips, and as widthwise, so how many are there? You have to say number of strips there. So let us say 20 strips this way, or 15 strips this way, and then 5, 6 strips this way. So 20 into 6, 120 strips you have to cast. So you have to sequence all those strips, all those imaginary strips. Actually, practically it will be that. Let us say 2-3 meters a strip, or 2.5 meter, whatever it is, and 15 strips this way, and 6 strips, 90 to 100. These strips must be sequenced on paper. The first wheel at the corner, then we go number 2 or 3, number 5, then we come back to number 1 and fill 2, or if you go to number top of that. Just like you have to do this, so that a sloping kind for angle is gradient kind, there's 30 degrees or 40 degrees or 45 degrees that, and in that way it should go. Provision is, requirement is that previous cast slip, earlier poured slip should remain hot, should not start setting, should not become cold, and when it is hot, another one should come in horizontal on top or side, and it should meet with that when you vibrate, interlock together, so that both remain in a state of hot concrete. That is the main purpose of stepping. We do not want to let it wait for 2 hours and get set, and then you will other one. That is unspecified. That is not correct one. Heated concrete should be connected to heated concrete, avoiding cold joint. That is sole purpose of method statement of such type of concrete. That method statement should also describe on plan where your pump shall be stationed, where your mobile pump shall be stationed, mobile pump, and where shall your truck comes and stays in, where shall you take slump, where should you take temperature, and how many positions will you take, 1 pump or 2 pump, and how many, means say one end or 2 end or other end, that end, depending upon location and size of your pour, and how you will do it, what's procedure of curing, what types will you start at. All that is given in method statement. What's the quantity of concrete, how many crews are there, all that you have to show. What timings of concrete, what is frequency of your trucks coming in, and all that must be shown on that method statement, which I am not giving, I just told you before also. Now you're going further, say about say differential thermocouples. You insert those thermocouples in that mass of concrete at locations, variables, and different depths you can do that, and that's for purpose of telling you temperature gradients or temperature, differential temperature at various depths and various locations, which must be within certain limits, so that it's not too heat or too different. Also difference on temperature, too much gradients are also not acceptable, and that's what's said. And normal curing is condemned, it's not doing normal curing there, then you can say concrete. In case of vertical joints, limitation of concrete volume is required. If so agree for joint formation, vertical joint is formed using metal. I told you this already. And I told you about the pre-test post-tension slabs. Then say question of pre or repropping pertinent PT slab is not clear. Slab can directly put on cast steel beam. So yes, that's right. Just told you fast tracking on this. Oh, yeah, pre-cast, no, pre-cast hollow are the hollow slabs are there. Just bring them on, put them on, and locate them on those beams, and then constitute one diaphragm. Procedure is there for fast tracking. And then columns, starter bars. What I said is that starter bar columns, you know, we start from foundation, take it once the overlap distance above floor level, above field level. Columns, the started bars are placed from substrate columns followed, but full length bar covering up to floor zero bending moment, location, avoiding moment area. So couplers, now questions of couplers overlapping is a question mark, because generally when bars are 20 or 20 mm or above, I don't think that overlap is very efficient. Overlap, oh, technically it's okay, calculation wise it's okay, but practically if you see, I can't trust that. So best thing is to avoid overlap with higher bars, because overlap length is 25, diameter is 50 mm, 50 dia and 25, so 25, 50, 125, ultimately you are going to use 125 additional length, and it's not very cheap as well. So what you can do, just connect two bars by some couplers. Mechanical couplers are available. It's much more than strength expected one, and you had test them. We tested this in tensile strength. So we got these bars fully okay, and you can place them both in compression resistance. You can put the columns or beams. These work very well, and these don't congest there also, and we can rely upon them, because we can't rely on you can say overlapping or welding. Welding also now is difficult to then examine or check, or you see radioactive test you have to take, X-ray tests can't take on that. So we say coupler is more reliable than we do in field by overlaps. So that's what a coupler can be used in both. Okay, the sign. Practically converting only one grade of concrete should be used. Better, I suggest, don't use different grades of concrete, columns and beams. But theoretically it's okay, but practically it doesn't matter. You lose quality control on that, you lose your standards on that. And about paving, I'm talking about pavers, because pavers are used to interlocking blocks. We call them concrete interlocking blocks. These are pressed items and 49 Newton according to the standards. You can increase that, it doesn't matter. Thickness is 80 mm for traffic area, and 60 mm for non-traffic area or walkways area, I can say. Other question is curing compounds, good replacement of water, but should be selective with caution, because curing compounds, there are two types of curing compounds. In-channel one is water-based curing compound, other one is wax-based curing compound. Water-based curing compound is less effective in wax-based compound, but better is evaporation with the evaporation water lost. But water-based curing compounds is efficient in a case that we can apply, and we don't feel any problem of the depth because it dries out, while wax-based curing compounds doesn't give that problem, but it forms a gelatinous layer on the surface of concrete, which takes about 6 months to go away or to degrade, and you can't wait for 6 months for purpose of plastering or something. So in that case, you have to apply your degrading compound to degrade that effect of chemical or wax, and or you have to scratch that immediately once curing is over, or else you have to wait for 6 months for that. Nobody can wait for 6 months. That was the purpose of that, but both are okay. Wax makes is more important, water-based, but water-based wax doesn't matter, Then prior to use compound water, you cannot simply say, why I have removed shuttering of beam, or I have removed shuttering of column, and I take this gun and fill it with a spring curing compound. No, that's not correct. Purpose of curing compound is to retain water on surface. It will not work as curing compound. You just spray on surface and say, I have sprayed. No, it will not work. It will not retain anything. You have to spray water on surface and then apply this compound, so that this compound constitutes a layer which protects that water retention, which protects the water already retained on the surface. It doesn't allow that water to evaporate, so it remains there. That's the purpose of this membrane. That's what's called membrane. It's not a material to cure concrete. That point must be clear. Water is written there on vertical surfaces. But on the horizontal surfaces, when we spray, this already water is there. On slab, we do immediately we spray that after it's done finishing. We don't wait for that shutting it in columns. We are waiting for shutting to remove and beam sides removed. Therefore, on slab you can directly already water is there. It won't go away. But one more thing, on horizontal surfaces, since you are going to walk on that after some time or next morning, when you walk on that, you damage that compound, that membrane. Therefore, that is only for preventive measure of crack formation immediately. Don't depend upon that. Next day you have to use your routine curing on slab. Lunch times there 6:54. Let us see how many more. Today actually I started a little late, so I'm late. So what I say, actually curing compound is never 100% effective on horizontal members that are accessible during curing duration. In addition to curing compound, water curing should be supplemented. Compound should be used only for avoiding initial cracks formation. That's all excellent. Now on what is that? On castings requires, but on all castings it is concrete. Reinforcement bars quantity for all. Yes, it's that. Well, when you place orders, you have to keep in mind quantity of steel as well. Though for calculation of quantity, we don't do that, but certain percentage, you just don't place order for whole concrete. Place order but for last delivery, 1 or 2 truck. Better if it's a big quantity or a small quantity, no problem. Maybe half cubic or 1 cubic will be different because steel is there, so volume is impacted upon practically. So we have to take that into our consideration, which is practical, it's on site. There's no explanation of that one. Let's say then, compressive character strength is object for at standard strength measurements for practical approval of concrete, so it doesn't make a difference. Now load testing, there's a problem. Load test, something happens, you have to load of 56 days, you have to wait for that. And something striking shut is required and early. Yes, you can strike shut early after cube is tested. You find a cube is resistance in 3 days, you can then say, okay, we strike shutter. Cycle of 12 days can be achieved. Forget that. That means how to do cycle. Then certainly soiling of the now question is that one is very important question. Now soil is involved in buildings. Foundation soil is there on that. The soil rest, and we call that water can move below soil. Below foundation, or it can pass through your foundation sides or on foundation tops. You can't stop this. Let us say there's a clay formation. So you fill with clay, of course, or filled there, you never know what to do then. Water comes and enters into pores of your clay, swelling its volume, and then doesn't go away. When it swells volume, either your building sinks off, the soil raises, means soil is impacted upon. Now what to do? Water doesn't guarantee anything, but it shall remain within soil, or it shall rise or not rise. Clay is very dangerous material, very dangerous cell, all that. While it comes in contact with water, it pours in, it restores water in, and that can swell. When it goes out, it dries out, that sinks in and it can building. So volume below, the soil below your foundation is subject to either swell up, expansion of volume, or reduce in volume, which both can cause settlement of building or upheaval of building, both. The worst solution? It's clay soil, it's black cotton soil, cohesive soil, deep, higher standard cohesion, not silt, I'm talking about clay. So what should be done? There is no guarantee of water. Water can keep moving in foundation, below foundation in soil. Only way is that we have to think over that. Don't be hurry in decisions. Better is, if soil, clay soil, you don't trust, remove that from there. Let us say you remove one, is 30 centimeter or 40 centimeter, 50 centimeter, depending on what soil foundation it is. You can remove that soil throughout your foundation and replace with granular material soil. Granular material in the sense from 40 mm aggregate to 12 mm aggregate, 6 mm aggregate. You fill in layers, put down 40 mm layers and fill with 12 mm aggregate, 20 mm and then 12 mm, and compact that by dust, replace dust. Compact that means your soil improvement is done by this granular layer, which acts like a sub base, or you can say like road below, through which, because it is granular material, it allows water movement. If there's not a turbulent water movement, but laminar flow below foundation, when comes up due to water table is raised, so something else happens, or rainwater comes in below, so this water can flow through your below foundation, this structure, that is granular material, and will not harm foundations, and this can keeps on moving from one place to other place, maybe in decades or in 5 years, 10 years. So we don't know what's happening in the water table, we don't check it daily, so this can cause a problem. That's what I said, use soil improvement. Then water soil mobility, I have told you, it doesn't harm concrete to considerable extent. What happens, even you avoid filling of clay also. It's not good for building. You can spend some money on filling of sand. It's much better than, so that you have to keep your liquid limit within 35 and your plasticity index below 6. If you increase liquid limit 35, it doesn't work, you see. Liquid limit and plasticity index are very important for the foundation, which point we should understand. At time of liquid limit, what happens? Soil starts losing shear strength. So that point is a must, Clay soil can be used for filling purpose in combination with desert fill and sandy soil, so that keeping liquid limit within 35 and plasticity index below 6, it's suggested that non-plastic soils should be used for filling purpose. The columns are designed for direct load as well as for movement, while shear wall is meant for primary legal loadings. So this is this question and answers which I had done somewhere now. Now it's there are more files I'll discuss with you. This is one hospital project file, then the practical training questions of concrete, technical questions. That's about technical questions. I'll just give you this technical question. The project management plan sample and safety all buildings. So these was the points. 15 minutes more. Let me see what can I give you more than this. These were files of knowledge areas, safety all buildings I have given you. So practical technical theory of concrete, project management plan, I'll do tomorrow, not today, this one. Then it is, we can say, I'll just bring you back some more information on Earth, because that's very important for a civil engineer. And there is a global lithosphere without which you cannot think further. Though maybe many of you know, yet many do not. So I'll just project again this diagram, this one. I do generally this because just to keep you abreast of that. What is this? I did last time also, but still for 2-3 minutes I can do this. This is your projection of Earth. Earth means this is lithosphere I'm showing to you. This is the lithosphere here. Internal is called core, intermediate is called mantle, and on top is called crust. Crust is 35 kilometers average, and size of Earth is 12,500 kilometers, whereas up to this center is 6,000 something. So, and up to end of your mantle is 3,000 something. So there are three important layers in Earth: 35, and then up to 3,000 and 6,000. This is basically, and densities are given here. This density is, you can say, first density is it's written 2.5 something. Means there are 3 types of densities given for this, and you understand that this is a rock. We call it crust is rock portion. Your sea is also there. Sea is up to 4 kilometers depth, and ocean is up to 10 kilometers depth. This is a part of crust, whereas mantle is different as a 5.5, and if you go inside you'll find more density. That's around 8,000 kilogram per cubic meter in core. You can see density is about 8,000 kilogram or 8,000 kilogram per cubic meter. It's like steel. So you can say core is like a steel, while rock is your crust, and if you go down it is 5.5, and you can say about 5.5. If you have density of 5.5, how shall you get density of? I think on that as an engineer, density of concrete cell is 2.5, and you want 5.5. How you get that? 5.5 density means you have to add steel shards into your concrete, because concrete is 2.5. If you say you use 50% of that steel shards, which is about 8, so 4 is there, 4 and then 2.5, which is 6.5, and little less of volume there. So that will be around, that means half of steel shards you have to add into 1 cubic meter of concrete, so that you can get density 5.5 or 5,500 kilogram per cubic meter. That is what 5.5 is. So you can see mantle is that powerful, because that much, and core is much more powerful, where crust is 2.5 on an average, 2,500 like rock or like concrete that is. And you see down pressure of water, and see, if you can see, go 4 kilometer down, what should be water pressure, go to 10 kilometer down, what shall be water pressure. And if that is water pressure there, if you take 4 kilometers down, which is about 4,000 means meter, 4,000 into 1,000, what's the value of that? 4,000 meter, WH we call in the intensity of that. So that is intensity of pressure there. What shall happen at that pressure? You can imagine yourself. What happened to that pressure? What will happen to rocks in that position? The rocks are only soft rocks there. So this must be crushed to some extent to get balance of these animals. And that's where we have used this earth, by pulling out on offshore, and taking out oil and all that. And this is your, release of strain energy at various locations is shown here, which awards you, this delivers you earthquakes here. So this was just a diagram I wanted to show you. I'm not going to show this is available on my videos. Somewhere you see that, you will find complete details of that. It's not time again. I'll take some water. I'm too thirsty. Hold on this moment. Take some water and go back then. Why I'm doing all this? Because these are very technical points, and many miss. I also used to miss them in my career, but later on I found it's easy. It's difficult. Without this knowledge, you have to discuss with the soil engineers. You have to understand what is soil report, investigation report, and you are not able to understand that because information, and that causes a problem in the field. Maybe you have to talk to someone else. You don't go through the report. Understanding of soil below foundation is very important subject. It's not easy, because soil is never uniform. Below foundations are varying. Board logos are there, board log reports are there, and there's so many board logs, and plate bearing tests are there, and many other tests are there. Value of N is there, RQ is there, total the core recovery is there, part core recovery is there. Those points we must understand, otherwise we face problems, because when report comes, we can't understand. We have to write report for on that report. What bearing capacity we are taking is recommended by some soil that soil technician or soil manager, that this what we are doing now. We can't understand that now. I think I should postpone this document. It's later on better. No purpose of this technique. I was talking to you about this quality issues, but quality cannot be talked in isolation. All these points are involved if you are to talk about quality, and I had those points which are actually, those points are there which actually I was about to continue, and these are assurance requirements. I was talking to you about this checklist of quality, which was one was setting out excavation I had done, then it was hand excavation I had done, checklist of formation I did, and after that it was checklist of for blinding concrete, which was done, checklist for concrete production waterproofing already done, checklist for foundation footing preparatory works already done, then stub columns preparatory works done. All I'm talking about is preparatory works for pouring, then checklist of backfilling works also done, then grade slab also done, then column works done, and then RCC walls work done, and then And then RCC lift well work done is long one, and then I also did for RCC longitudinal staircase works, they already finished, and RCC suspended slab works item 40 is done. After that, your pedestal footings also done, and pedestal footing means steel frame, and then RCC footings blocks for steel frame, and then DC generator and alternative foundations I have done. And after that, this is fair face structure walls with the architectural finish works, RCC architectural finishing works, and then it was RCC Howdy slab, HOURD Howdy slabs works, and a sloping portion floor slab work, and then also sloping portion suspended slab works already done, and then it was RCC heavy compressor foundations already done. Then it was tabletops and done, and tabletops works checklist. Then it was RCC swimming pools I had done, and it was then shooting range I had explained also, and then it was item of footing concrete pour that was done yesterday. Item number 6 previous item in 28 it was done, and then that was checks. This is check stub columns, and this item 7 and 28. And this was said that I just take this and finish because time is already 3 hours or more. And then its item was plan adequate number of stubs, stub columns, we call it stubs, to be poured in one go to meet RMC delivery requirement. Book concrete in advance to facilitate RMC supplier to chart out RMC plant schedule. Factually, it would be inconvenient for RMC supply to a small quantity. Book concrete pump of required boom length in case stub course is required by pump, but stubs may also be done using pumpless pour. That's not a problem if you can manage. Check that stubs are not more than 2 meters high in general. Check that site provided means are feasible for pouring RMC. Check if site pour means are utilized. RMC should not be delayed excessively during pouring. Check that all stubs planned for pouring are safely accessible for pour gang. Make sure mason's tools are available. Make sure adequate number of carpenters and steel fixers are in attendance for meeting certain low profile emergency. In case of concrete pump being used, make sure that only required quantity of mix is poured into stub to prevent concrete from dropping around stub preliminary works. Then ensure vibrator is applied rightly into stub portion without touching reinforcing bars or forms. In case vibrator touches forms, changes of form opening are not acceptable. Then chances of form opening are not applicable. Check all curing materials required for stubs are available on site, including curing compound. While concrete truck arrives, collect sample for some air voids, etc. Check loading and delivery time, and also check RMC dockets. Allow truck to move into location station for delivery. Check site prepared open chutes. Check site prepared open chutes are available in case of pumpless concrete, so that concrete can be easily transported to stubs. In certain cases, steel wheelbarrows can also be used for transporting concrete from trucks. Some small buckets can also be used for collection of concrete and pouring into stubs. Mobile or tower crane can also be used for pouring stubs if available. Make sure the stub is connected in layers, concreted in layers and not exceeding 40 to 50 mm, 500 mm deep. Make sure that vibrator is efficient use. After laying pouring. Make sure that after pouring steps to their marked top level, top is covered with polythene or Hessian as convenient. Make sure no supports are slackened during pouring. While using pumpless pour, there are remote chances of foams opening, but with pump chances are more. Then make sure that foreman or charge hand forward charger type supervisors do not allow water to be added to concrete during pouring. It often happens that during long pour and concrete truck getting delayed, concrete stuff is stiffened, causing hardship to workers. To avoid that, they tend to add water to mix, which is not acceptable in any case. Start curing after few hours depending on the temperature, but sides of forms externally can be kept cold by spraying water. Side forms can be removed after 24 hours to 36 hours, but it takes time while opening. Regards. Now checklist for grade slab. This will do next day. Is not time now, I think. It's already late, and it is. Who is this? Yeah, why is disturbing? I don't know what these people want. Unnecessary calling, disturbing my concentration. These people are having no work at all. I don't know why they call. And so say, I will tell that what is calling so many people up. Are you there? Why are you wasting my time? If you come and talk, just showing dark is no meaning. Who are you, Mr. Ajay? Are you there? Or I put off? If you don't notice, I'll block you now. What does it mean? I don't understand their behavior. Stupid people. I made a mistake to friend with me. Such stupid guys. Well, I'll close it now because already late now. Sometimes you are disturbed for nothing. Thank you very much, gentlemen. Tomorrow we'll take further actions on this, and it will be checklist for this is now floating slab. I'll talk to you. It's pouring of floating slab, then column concrete pour, and all that are balanced. We'll talk tomorrow. Thank you very much, because I'm now. So, anybody there also? Nobody else? All right. Thanks.